Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a tool for you to practice for your entrance exams. There's a number of entrance exam question papers along with the detailed solutions and PDF. You can also download our app. The link is available in the description box. So let's move further to solve today's paper. Today we'll be solving AAPCET 20 August 2021 shift 1 paper. All right, so we'll be solving around 80 questions for this paper. Let's start with question number 1. Here we go. You are given fx is equal to fx is equal to sine x plus cos x. Gx is x squared minus 1. And you have to find the g of f of x. That is equal to sine x plus cos x whole squared minus 1. This is equal to 1 plus sine 2 sine. Okay, wait, I will not go directly. I'll write properly. So sine square x plus cos square x plus 2 sine x cos x minus 1. So this is gonna give me, see, this is equal to 1 and this is 1. So these two will cancel. Sine square x plus cos square x is equal to 1. You know this. So this is equal to sine 2x. Let's make a graph of it. So this is the graph. Net x is, this is pi by 4, pi by 2. There is minus pi by 4 and minus pi by 2. So the function looks something like this. Like this. Right? So the function is somewhat like this. This actually is got to be here. Fine. So this is the function among the given options. See, you're given, this is the equation, this is the graph for sine 2x. So among the given options, if I look at these options, from these options, sine 2x is monotonous. Here, strictly increasing. In minus pi by 4 to pi by 4 range, which is option A. So this is the correct answer to the question. Hope you understood this. Let's move to the next question, number 2. If f is a function from integers to integers is defined by this, fx is equal to this whole expression for all x belonging to integers, then f of 11 is equal to. Actually, this is an easy question, really. You are given fx is equal to x raised to power 9, 11 x raised to power 8, 2 x raised to power 7 plus 22 x raised to power 6, x raised to power 4, 12 x cubed plus 11 x square plus x minus 3. Now, yeah. So if I'm putting, let's solve it a bit. So directly, if I'll fill 11 x is equal to 11 raised to power 9, this is going to be really tough for you to solve. So I'll do what? I'll say x raised to power 8, I'll take common. This will be x minus 11 minus 2 x raised to power 6, x minus 11 plus x cube x minus 11. So you have these factors, x minus 11 into x raised to power 8 minus 2 x raised to power 6 plus x cube. There is more to it. Minus x square, x minus 11 plus 1 into x minus 11 plus 8. Okay. So this is 8 x raised to power 8 minus 2 this plus x raised to power 3 minus x square plus 1 plus 8. Right. Now, this is one of the factors for f of 11. This becomes 11 minus 11 into 11 raised to power 8 2 into 11 raised to power 6, 11 raised to power 3, 11 square plus 1 plus 8, that is equal to 0 plus 8, or 8 is the answer. That is option B. Hope you understood this. Let's move to the next question number 3. Let fx is equal to x cube, gx is equal to 3 raised to power x, and the quadratic equation whose roots are solutions of this equation for x not equal to 0 is. Okay, you have fx is equal to x cube, gx is equal to 3 x raised to power x. F of g of x is equal to g of f of x. It's given in the question. So f of g of x, that means 3 raised to power x raised to power 3 is equal to 3 raised to power x raised to power 3. That means 3 raised to power 3x is equal to 3x raised to power 3. Fine. Equating the bases, you have 3x is equal to x raised to power 3, or x raised to power 3 minus 3x is equal to 0, which makes x into x squared minus 3 is equal to 0. So that means, see, in the question we are given x is not equal to 0, which means x squared minus 3 is equal to 0, or x squared is equal to 3. Yeah, option D is the answer. Hope you understood this. Next is question number 4. The trace of the matrix A is, you have to find the trace of it. Pretty easy. Trace, what do you mean by trace of any matrix? Trace of matrix is sum of diagonal elements, sum of its diagonal elements. So the matrix is A, which is given by 1 minus 5, 7, 0, 7, 9, 11, 8, 9. The diagonal elements are this. So trace of A is 17. Option A. Hope you got that. Next is question number 5. If A, B, C are the angles of the triangle, then the system of these equations. This is 1, 2, and 3. So these 3 equations have 0 solution, non-zero solution, only 0 solution, but for certain values of ABC, non-zero solution if triangle ABC is equilateral and not for all the triangles. So these are some of the options. You have to find out what these system of equations satisfy. Okay. So we just talked, this is first, second, and the third equation. Let's write them in the matrix form. So in the matrix form, this will be given by minus 1 y cos C cos B cos C cos A minus 1 cos B. Sorry, I have written this wrong. Wait, I'll write it again. That's minus 1 cos C cos B, and cos C minus 1 cos A cos B cos A minus 1. Let's find the determinant. You have minus 1 minus cos square A plus cos C cos A cos B plus cos C, and plus cos B cos A cos C plus cos B. This is minus 1 plus cos square A plus cos A cos B cos C cos square C plus cos A cos B cos C. I'll just write 2 over here. Okay. So plus cos square B. Fine. So this is cos square A minus 1, which becomes minus sine square A plus cos square B plus cos square C plus 2 cos A cos B cos C. Right. So clearly over here, if you see this, this is clearly this delta is greater than 0. Represent this with delta. So clearly this equation is greater than 0. Therefore, the system of equations have non-zero solution because it's not equal to 0. Have non-zero solution. That is option B. Hope you understood this. Let's move to the next question, number 6. Okay, so you have if 1 minus tangent of theta tan theta 1 this matrix into this matrix is equal to this matrix, then which of the following is true for A and B values? So you are given, let's say this is A and let's say this is B. Okay, so if I have this matrix, not A, this is B, wait, this is A and this is A transpose. Look at this. This is 1 minus tan theta, 1 minus tan theta 1. So this is A, then this is A transpose. Okay, fine. So if I'll start off from here. A is given by 1 minus tangent of theta 1. Inverse of A will be given by adjoint of A. Question number 6, if 1 minus tan theta 1 into this matrix is equal to this matrix, then which of the following value for A and B is true? Let's say this is equal to A. So A is given by 1 minus of tangent theta and 1. Right. A inverse is given by adjoint of A divided by determinant of A. Let's find the determinant of A first. That is 1 minus tan squared theta, 1 plus tan squared theta. Wait. So this is 1 minus of minus tangent squared theta, which is equal to 1 plus tangent squared theta, and that is equal to secant squared theta. And what about this adjoint of A? That is written as 1 minus this. Question number 6, if 1 minus tan theta 1 multiplied by 1 tan theta minus tan theta 1 inverse is equal to A minus B, B A matrix, then which of the following is a true value for A and B? I'll say this matrix, let's say this is A. So A is written as 1 tangent of theta minus tangent of theta 1, and A inverse is written as adjoint of A divided by determinant of A. A determinant is given by 1 tangent theta minus tangent theta 1, that is equal to 1 minus plus tangent squared theta, which is equal to secant squared theta. So here A inverse becomes 1 upon secant squared theta into adjoint of A, which is 1 tangent theta minus tangent theta 1. All right. So you got this A inverse. This was A. We assumed this to be A and we got the A inverse. Let's say this is B. So we have to find B A inverse. What was B equal to? 1 minus tangent theta 1. And E was this. So this can be written as 1 upon secant squared theta 1 minus tangent theta 1 minus tangent theta 1. Let's multiply first row, first column. you will have 1 minus. So 1 minus tangent square theta, and minus tangent theta minus tangent theta. This will be minus 2 tangent theta. Tangent theta plus tangent theta, 2 tangent theta, and this is minus tan theta plus 1. So this is 1 minus tan square theta again. So let's fill in inside. You have, I'll take secant square theta inside. So you have here cos square theta minus sine upon cos. So this will be sine square theta. 1 minus sine square theta upon cos square theta multiplied by cos square theta, because secant square theta is 1 upon secant square theta is cos square theta only. So this will be equal to cos square theta minus sine square theta. Hope you understood this. And this further will be written as minus 2. Tangent theta is sine theta upon cos theta multiplied by cos square theta. So this will be minus 2 sine theta cos theta. Similarly, over here, you will have 2 sine theta cos theta, and this will be cos square theta minus sine square theta. This is the formula for cos 2 theta. This is minus sine 2 theta, sine 2 theta, cos 2 theta. This was equal to A minus B, B and A. So you have A as cos 2 theta and B as sine 2 theta. These are the two values. Option B is the answer. Hope you got that. Next is question number 7. If Z1 is 2 plus 3 iota, a complex number problem, Z2 is 3 plus 2 iota, where iota is, this is root of minus 1, then you have to find the product of these two matrices. Fine. So first thing, you are given, let's write down Z1 and Z2. Z1 is 2 plus 3 iota. Z2 is 3 plus 2 iota. And you are given, you have to find the product of these two matrices, Z1, Z2 minus Z2 conjugate, Z1 conjugate, Z1 conjugate minus Z2, Z2 conjugate, and Z1. Let's find the product of them. You have Z1 into Z1 conjugate. This is okay. And then you have Z1. Wait. First row, first column. Okay, wait. Question number 7. If Z1 is equal to 2 plus 3 iota and Z2 is equal to 3 plus 2 iota, where iota is equal to minus of root of minus 1, then you have to find the product of these two matrices. I'll start with Z1. You are given Z1 is equal to 2 plus 3 iota and Z2 is equal to 3 plus 2 iota. Let's find the magnitude of both of these vectors. Complex numbers. So this is 2 square plus 3 square, which is 4 plus 9, that is equal to root of 13. And Z2 is equal to root of 3 square plus 2 square, which again is root of 13 magnitude. Okay. Now let's go with the matrices. You have Z1 into Z2 minus Z2 conjugate, Z1 conjugate, Z1 conjugate minus Z2, Z2 conjugate, and Z1. Let's multiply them now. First row, first column, you have Z1 into Z1 conjugate plus Z2 into Z2 conjugate. So here is Z1 minus Z1 into Z2 plus Z1 into Z2. Here is minus Z1 conjugate into Z2 conjugate. Wait, sorry. Yeah, Z1 conjugate into Z2 conjugate plus Z1 conjugate into Z2 conjugate. And here you have minus minus plus, so Z2 into Z2 conjugate plus Z1 into Z1 conjugate. This will cancel out and you have, see, Z into Z1 conjugate. Whenever a complex number and its conjugate are multiplied, this is nothing but equal to the magnitude of that complex number square, right? If you are having Z is equal to X plus iota Y, then Z conjugate will be given by X minus iota Y, and the dot product of the two will not be nothing but the magnitude of the complex number square. So this is equal to Z1 magnitude square plus Z2 magnitude square. Here was 0, 0. Similarly, Z2 magnitude square plus Z1 magnitude square. And the magnitudes of the two, we just calculated before, it is root 13 in each of the case. So this becomes equal to root of 13, that square, which gives you 13 plus 13, 0, 0, 13 plus 13. That is 26, 0, 0, 26. I'll take 26 outside. So this is 1, 0, 0, 1 or 26 into the identity matrix. That is option C. Hope you understood this. Next is question number 8. What is the value of this matrix equal to? Okay, it looks tough, but pretty easy. Let's start with it. You are given A, B, C, A minus B, B minus C, C minus A, and B plus C, C plus A, A plus C. This is the given matrix. Let's perform some transformations. Let's change R1 to R1 plus R3. If you do so, you will get ABC, A plus B plus C, A plus B plus C, A minus B, B minus C, C minus A, B plus C, C plus A plus B. I'll take A plus B plus C common from the first row. You will have A plus B plus C, 1, 1, 1. A minus B, B plus C, B minus C, C plus A, C minus A plus B. So let's perform some more transformations. Now I'll perform R2 as R2 plus R3. Okay. This will be 1, 1, 1. And this will become A plus C. This will be B plus A, C plus B. B plus C, C plus A plus B. Next, further, some column transformations. C2, let's change into C2 minus C1 and C3 to C3 minus C1. Actually, I want to get eliminate of these ones. Okay, this is my motive over here. So you will have this as A plus B plus C, 1, A plus B, B plus C. Here will be 0, B minus C, A minus B. Here will be 0 again, B minus A minus C. Now let's expand it using the first row, first column. You will have A plus B plus C will be there for sure. And next will be B minus C into A minus C minus B minus A into A minus B. That is equal to A plus B plus C. Let's open. This is AB minus BC minus CA minus plus C square minus BA plus B square plus A square minus AB. So this and this will cancel and nothing else, I think. So you have A plus B plus C, A squared plus B squared plus C squared minus AB minus BC minus CA. This is the formula for this whole thing. Wait, this whole thing is the formula for A cube plus B cube plus C cube minus 3ABC. This whole thing is the formula for this. Right. So the answer to the question is Let's write it properly. A cube plus B cube plus C cube minus 3ABC. Let's check with the options. You have option B as your answer. Hope you understood this question. Let's move to the next question number 9. The radius of the circle, which is represented by 1 plus iota into 1 plus 3 iota into 1 plus 7 iota, is equal to x plus iota y, where you know iota is equal to root of minus 1 is given by. So you are given 1 plus iota, 1 plus 3 iota, 1 plus 7 iota is equal to x plus iota y. Let's solve. You will have it as 1 plus 3 iota plus iota plus 3 iota square into 1 plus 7 iota. This is equal to, see, this will be 3 iota square will be equal to 3 into minus 1, which will be minus 3. So you will have here minus 3 plus 1 minus 2 plus 4 iota into 1 plus 7 iota. This will be minus 2 plus 4 iota minus 14 iota plus 28 iota square is equal to x plus iota y. So 28 iota square will be equal to minus 28. This is minus 30 minus 10 iota is equal to x plus iota y, which makes x is equal to minus 30 and y is equal to minus 10. Right. What do you have to find out? The radius of the circle. So the radius of the circle is, see, x plus iota y was minus 3 minus 10 iota. Radius is given by minus 30 square plus minus 10 square, which is equal to 1000 root. That is 10 root 10. So this is the radius of the circle. Option B is the answer. Hope you understood this. Let's move to the next question, number 10. If L1, alpha 1, alpha 2, alpha 3, alpha 4 are the roots of this equation, omega is the cube root of units, then omega minus 1, omega minus alpha 1, omega minus alpha 2, omega minus alpha 3, minus alpha 4 plus omega is equal to. Okay, you are given that these are the roots of this equation. If these are the roots of this equation, then that means z minus 1, z minus alpha 1 into z minus alpha 2, z minus alpha 3 into z minus alpha 4 is equal to z raised to power 5 minus 1, right? Also, you have to find out omega, question number 10. If 1, alpha 2, alpha 3, alpha 4 are the roots of z raised to power 5 minus 1 is equal to 0 and omega is the cube root of units, then omega minus 1, omega minus alpha 1 minus alpha 2 minus alpha 3 minus alpha 4 plus omega is equal to what? Okay, so here you are given that these are the roots of z raised to power 5 minus 1. Since these are the roots of z raised to power 5 minus 1, therefore you can write them like z minus 1 into z minus alpha 1, z minus alpha 2, z minus alpha 3, z minus alpha 4. This is equal to z raised to power 5 minus 1. Then if this is true, then omega 1, omega minus 1, omega minus alpha 1, omega minus alpha 2, omega minus alpha 3 minus alpha 4 is equal to omega raised to power 5 minus 1, right? See, omega raised to power 5, this is equal to omega square. I hope you know this because this is equal to omega, this omega cube into omega square. Omega cube is 1, so this is equal to omega square only. Fine. Now I'll get back to this equation. This is, see, I missed plus omega over here. Okay, sorry. Yeah, so omega 1, omega minus 1, 2, 3, and 4 is equal to omega square minus 1. You know one more identity. 1 plus omega square is equal to 0. If I'm saying this is omega square minus 1, so this will be equal to minus omega minus 2. Okay. So this is equal to omega, this, omega 2, omega 3, alpha minus, sorry, omega minus alpha 3, omega minus alpha 4 is equal to minus omega minus 2, right? So I'll take this omega on the right hand side now. Omega minus alpha 1 minus alpha 2, alpha 3 minus alpha 4 plus omega is equal to minus 2. And this is what you needed to find out, right? This is equal to minus 2. So you have option C as the answer. Hope you understood this. See, I'm repeating the whole sum once again. You are given that these are the roots of this equation. If these are the roots of this equation, you can write down z minus 1 into z minus alpha 1, z minus alpha 2, z minus alpha 3, z minus alpha 4 is equal to z raised to power 5 minus 1. So if I replace that z with omega, you will have this equation. So omega raised to power 5 can be written as omega square. So this is equal to omega square minus 1. Omega square minus 1 is equal to minus omega minus 2. I'll take this omega on the right hand side now. This will be plus omega. This was missing. So this will be filled over here. So the answer to the whole expression becomes equal to minus 2. Hope you understood this. Next is question number 11. You are given if a is greater than 0 and z is given by x plus iota y, then log cos square theta z minus alpha is greater than log cos square theta z minus a iota, where theta belongs to the real number, implies which of the following option to be true. Fine. You are given a is greater than 0 and z is equal to x plus iota y, which gives you log of cos square theta z, it's given greater than log cos square theta z minus a iota. You know one thing that cos square theta lies between 0 and 1 only. So also z minus a, this is always less than z minus a iota, right? If this is less than this, then z, this was equal to x plus, this will be x plus a, like I'm concatenating the real part, plus, sorry, x minus a. Okay, I'll write it like this. X plus iota y minus a is less than x plus iota y minus a iota. This makes it x minus a plus iota y, x plus y minus a iota. Let's find the mod of it, magnitude of it. This is given by root of x minus a square plus y square is less than x square root plus this. Squaring both the sides, you will get x square plus a square minus 2ax plus y square is less than x square plus y square minus 2ay. What I'm missing? A square. Okay, so this gives you x square, y square, this will cancel, even the a square will cancel, minus 2ax is less than minus 2ay, which gives you x is greater than y. So this is it, x is greater than y, this is option A. Hope you understood this. Next is question number 12. If one root of this equation is 2 minus iota, then the other root is, okay, you are given iota x square minus 2 iota plus 1x, 2 minus iota is equal to 0. So one of the roots is given as this. Let the other root be alpha. So you have x minus 2 minus iota into x minus alpha is equal to 0. Let's open up. You will have x square minus 2 minus iota plus alpha x minus alpha 2 minus iota is equal to 0. Now, if I compare it with this equation, comparing 1 and 2, you have iota x square minus 2 iota plus 1 plus alpha iota x minus alpha into 2 iota plus 1 is equal to 0. See, what I have done over here is I have multiplied the second equation with iota to make it look at similar, because I have to compare 1 and 2. So I have multiplied the second equation with iota. Now let's compare 1 and 2. You will get this is equal to this and this is equal to this. Okay. So now comparing 1 and 2, you will get 2 iota plus 1 plus alpha iota, which is equal to this one, is equal to 2 iota plus 1. Right? 2 iota plus 1 plus alpha iota is equal to 2 iota plus 2. This will cancel and you will have alpha iota is equal to 1, or alpha is equal to 1 upon iota, which can be written as minus iota square upon iota, which is nothing but minus iota. So this is the answer. The other root is equal to minus iota. Option B. A. Hope you got that. Let's discuss the whole sum once again. If one of the root of this equation is 2 minus iota, you have to find the other root. Let that root be alpha. If this is the root, then x minus 2 minus iota into x minus alpha, because these are the two roots, the product is equal to 0. I'll open this up. So this becomes x squared minus 2 minus iota plus alpha into x is minus alpha 2 minus iota is equal to 0. Now I have to compare 1 and 2, but here was the iota was missing. So in that case, I have multiplied this equation with iota, which makes it iota x square minus this whole thing. Like this whole thing will come over here. Okay. So if I compare now this part, because this is the coefficient of x, becomes equal to this part. Okay. Which makes 2 iota plus 1 plus alpha iota is equal to 2 iota plus 1, which gives you alpha is equal to minus iota. Hope you understood this. Let's move to the next question, number 13. It's given alpha and beta are the roots of this quadratic equation. Then the equation whose roots are this, and is given by which of these equations? Okay. The given equation is x square plus x plus 1 is equal to 0. Let's write it. So alpha and beta are the roots of this quadratic equation. The roots of this quadratic equation are given by, see, omega. So alpha will be omega and beta will be equal to omega square. These will be two roots of this equation. Now, see, look at this one, where what will be the omega? Omega is given by minus 1 plus minus plus root 3 iota upon 2, and omega square is minus 1 minus this, and omega cube is equal to 1. Now you have to find out alpha raised to power 2021, which is nothing but omega raised to power 2021. And this can be written as omega cube into, see, if I divide this 2021 with 3, you have 6, 7 and 7. No, sorry, 3. 673 into omega square. Omega cube is equal to 1. So 1 raised to power 673 into omega square. This is equal to omega square itself. And beta raised to power 2021. Similarly, it is beta was equal to omega square into 2 raised to power 2021. This is equal to omega 4042. Let's do the same thing. I'll multiply 4042 with 3. So you have 1, 3, 4, and 7. So you have omega cube raised to power 1347 into omega square, which is again equal to 8. Equation number 12. If one root of the equation iota x square minus 2 iota plus 1x plus 2 minus iota is equal to 0 is 2 minus iota, you have to find out the other root. Okay, so you are given this equation. Let's say other root is alpha. Let the other root be equal to alpha. So what the equation will be, since I'm having the one root as 2 minus iota and another root as alpha, so the equation will be given by x minus 2 minus iota into x minus alpha is equal to 0. Which gives me, let's open it up, you will have x square minus 2 into iota plus alpha into x minus alpha into 2 minus iota is equal to 0. So let's say this is equation 1, the given one. This is equation 1 and this is equation 2. Now I want, since these two equations should be equal, like we have to compare them. But iota is missing over there. So do one thing, let's multiply both the sides by iota. You will have iota x square minus, this will be 2 iota minus iota square, that will be plus 1 plus iota alpha into x minus alpha into 2 iota plus 1 is equal to 0. Right? Let's say this is equation 2. Now let's compare equation 1 and 2. Comparing equation 1 and 2, you will get, see, 2 iota plus 1 plus alpha iota is equal to 2 iota plus 1. Let's write 2 iota plus 1 plus alpha iota is equal to 2 iota plus 1. So this is 2 iota plus 1 plus alpha iota is equal to 2 iota plus 1. And you will have here, sorry, plus 2. Yes, plus 2. So 2 iota and 2 iota will get cancelled. Alpha iota is equal to 1, which gives you iota, sorry, alpha is equal to 1 upon iota, which can be written as minus iota square upon iota, or this is equal to minus iota. That's it. You needed to find out the value of alpha. That was the other root, that is minus iota. So option E is the correct answer. Hope you got that. Let's move to the next question. Question number 13 is alpha and beta are the roots of this quadratic equation. Then the equation whose roots are alpha raised to power 2021, beta raised to power 2021 is. Since this is the given equation, so roots are alpha and beta. So for this equation, you know the cube roots, the roots are given by omega and omega square. What is the value of omega here? It is minus 1 plus root 3 iota upon 2. And you know omega cube is equal to 1. Right. I have to find out alpha raised to power 2021, which is given by omega raised to power 2021. Let's divide this with 3. So 2021, if I'm dividing this with 3, I will get 6, 18, 22, 7, and wait, 22. So this is 21, this is 11, this is 3. So this is 6 omega raised to power 673 into omega square. Right. Omega raised to power 3 into 673 into omega square, which is equal to 1 into omega square or omega square itself, because omega cube is equal to 1. Second root, beta raised to power 2021. That is given by beta raised to power 2021. See, beta is equal to omega square, right? So this is 2 into 2021. This is equal to omega this raised to power 2 into 2021, sorry, 673. Omega raised to power 2 into 8. I'll change the color. So that is into 673 into omega raised to power 2 raised to power 2. So this is equal to 1 multiplied by omega raised to power 4, which is equal to omega cube into omega, or that is equal to omega. Right. I got the two values for alpha raised to power 2021 is equal to omega square, and beta raised to power 2021 is equal to omega. Now the two roots are x minus omega square is equal to this. Right. So we have option D as the answer. Hope you understood this question. Next is question number 14. If 2, 1, 1 are roots of this equation, then the roots of x plus 1 upon 3 raised to power 3 minus 4 into x plus 1 by 3 square plus 5 into x plus 1 by 3 minus 2 is equal to. See, this is the function fx is equal to x cube minus 4x square plus 5x minus 2 is equal to 0. And let's make the graph for this. If I have to make the graph will look something like this. So these are 2 points where it is intersecting the x-axis. So it is given 2, 1, 1. The other roots of this equation, then the roots of this are. Now this is particularly the graph for this function. And the graph for f of x plus 1 upon 3 will shift towards left by 1 by 3 units. Will shift towards left by 1 by 3 units. So the new roots will also shift by 1 by 3 units towards left. So now the roots will be 1 minus 1 upon 3, 1 minus 1 upon 3, 2 minus 1 upon 3. This gives me 2 by 3, 2 by 3, and this is 5 by 3. So this is the answer to the question. Option B is the correct answer. Hope you got that. Next is question number 15. fx is 2x cube plus mx square minus 13x plus n, and 2 and 3 are the roots of this equation. Then the values of m and n are. Okay, the given function is 2x cube plus mx square minus 13x plus n. So this is a cubic polynomial. Therefore, this will have 3 roots. Let alpha, beta, and gamma be the 3 roots. 3 roots of fx is equal to 0. Now 2 and 3 are the roots of this equation. Let's say alpha is equal to 2 and beta is equal to 3, and let's say gamma is equal to some k. Now, you know, sum of the roots is equal to minus b upon a. This is sum of the roots. That is minus the coefficient of x square upon 2. Minus m upon 2. So this is 2 plus 3 plus k is equal to this, which gives you 2 plus, this is minus m is equal to 2 into 5 plus k, or minus m is equal to 10 plus 2k. Okay. Now, second, this is, let's say this is equation 1. The second one, the sum of product of the roots. Sum of product of roots is given by C upon A. That is alpha into beta plus beta into gamma plus gamma into alpha is equal to C upon A. That is minus 13 upon 2. This is minus the coefficient, the coefficient of x divided by the coefficient of x cube. So minus 13 upon 2. Okay. This will be given by alpha and beta. So this is 2 into 3. Beta was 3 into k plus gamma was k into 2 is equal to this. This gives me 5k is equal to minus 13 by 2 minus 6. Okay, which is equal to minus 25 upon 2. Now, product of the roots, that is given by minus d upon a. So, product of roots is minus d upon a. So, this is equal to minus n upon 2. Right, and this is equal to 2 into 3 into k, which is equal to 6k, or minus n is equal to 12k. Let's say this is equation 3, this is equation 2. So let's see the equation ones. See, from equation 2 you have 5k is equal to minus, from equation 2 you have 5k is equal to minus 25 upon 2, which gives me k is equal to minus 5 upon 2. So now from equation 2, 3, minus n is equal to 12k, which is equal to 12 into minus 5 upon 2, which is equal to minus 30. And from equation 1, you have this. From equation 1, you had minus m is equal to 10 plus 2k. Minus m is equal to 10 plus 2k. Minus m was equal to 10 plus k was minus 5 upon 2. So this gives me 5, which gives me m is equal to minus 5. You had to find out the value of m and n. M is minus 5 and n is here n is equal to 30, because minus n was equal to minus 30. This gives me n is equal to 30. M is minus 5 and n is equal to 30, which is option B. Hope you understood this. Next is question number 16. The value of 6p4 plus 4 into 6p3 is pretty easy question actually. So 6p4 will be written as a general formula for npr is equal to n factorial upon n minus r factorial. So this is 6 factorial upon 6 minus 4, that is 2 factorial, plus 4 into 6 factorial upon 6 minus 3, that is 3 factorial. So this is equal to 6 into 5 into 4 into 3 plus 4 into 6 into 5 into 4 into 3 factorial, they will cut, and similarly 2 factorial, they will cut, and here you are having 12 30s are 360 plus this will be 480. So the total comes out to be 840. That is option C. Hope you understood this as well. Next is question number 17. The number of ways in which 3 boys and 2 girls can sit on a bench so that no 2 boys are adjacent is. Fine. You have 3 boys and 2 girls. So the only possible arrangement so that no 2 boys are sitting together is given by, here is boy 1, boy 2, boy 3. So only if the 2 girls, they are sitting between them. Okay. Now G1 and G2, these 2 girls, G1 and G2 can be arranged in 2 factorial ways. Can be arranged in 2 factorial ways, and B1, B2, B3 can be arranged in 3 factorial ways. Right. Yeah. So the required number of arrangements is required number of arrangements is equal to 2 factorial multiplied by 3 factorial. This is 2 into 6. That is 12. Option C is the answer. Hope you understood this. Next is question number 18. In how many ways can 5 balls be placed in 4 tins if any number of balls can be placed in any tin? So you have 5 balls that has to be placed in 4 tins. So each ball can be placed in 4 ways. Can be placed in 4 ways. So the number of ways will be for 5 balls. So number of ways of placement is equal to 4 into 4 into 4 into 4 into 4. So I'm raising it to 5, like 5 balls are there. So one ball can be arranged in 4 ways. 5 balls can be arranged in 4 raised to power 5 ways. That is option C. Hope you understood this. Let's move to the next question, number 19. Given 3x minus 2 upon this is equal to a upon x plus 1, b upon x plus 1 square, c upon x plus 3. Then 4a plus 2b plus 4c is. Fine. This is the equation like, see, let's take the LCM. So taking the LCM and cancelling the denominators, you will get 3x minus 2 is equal to a into x plus 1 into x plus 3, b into x plus 3, c into x plus 1 whole square. Now, okay, if I put in this question, if I put x is equal to minus 1, see, directly no need to open up the brackets. This will take a long time. So if I'm putting x is equal to 1, this will become 0, the first term, and the last term, this will become 0. And if I'm putting x is equal to minus 1, I'm having minus 5 is equal to b into 2. That is 2b is equal to minus 5 or b is equal to minus 5 upon 2. Okay. Now, if I put x is equal to minus 3, then the first term and the second term will be equal to 0. And this will be minus 9 minus 2, that is minus 11. So minus 11 is equal to c into minus 3, that is 2, that is equal to 4. Okay, minus 2 square is 4. So c will come out to be minus 11 by 4. Now next, if I put x is equal to 0. If I'm putting x is equal to 0, what you will have over here? Minus 2 is equal to 3a, 3b, and c. Okay. I have already got the values of b and c. Let's fill in this question. You have 2 is equal to 3a plus 3 into minus 5 upon 2 minus 11 upon 4. So 3a is equal to minus 2 plus 15 by 4. Right, this is, and this is also plus 11 by 4. Okay, now taking the LCM, you have 4 minus 8 plus 15 plus 11 is equal to 3a, or 3a is equal to, this is 18 upon 4. So a comes out to be given 3x minus 2 upon x plus 1 square into x plus 3 is equal to a upon x plus 1 plus b upon x plus 1 square plus c upon x plus 3. Then you have to find out 4a plus 2b plus 4c. Basically, you have to find out a, b, c. So you will get your answer. Fine. And now I'll be doing what? I'll be taking LCM and cancelling the denominators. I will get 3x minus 2 is equal to a into x plus 1, b into x plus 3. This is a into x plus 1 into x plus 3 plus b into x plus 3 plus c into x plus 1 square. Right. So now if I put x is equal to minus 1, see the first term and the last term, this will be 0. You will have a minus 5 is equal to b into 2, or b will be equal to minus 5 upon 2. If I put x is equal to minus 3, then the first and the second term will vanish and you will have minus 9 minus 2, that is minus 11 is equal to b into, c into, that is equal to minus 2 square, that is 4. So c comes out to be 11 by 4. You got the value of b, you got the value of c. So next I have to find out a. If I put x is equal to 0, this will be minus 2 is equal to 3a plus 3b plus c. Minus 2 is equal to 3a I have to find out, and b was equal to minus 5 by 2, c was equal minus 11 by 4. So you have 3a is equal to minus 2 plus 15 upon 2. Minus 2 plus 15 upon 2 plus 11 by 4c. Sorry, c is not there. Okay, c we have filled in the value. Right. So let's take the LCM. 4 minus 8 plus 30 plus 11. This is equal to 33 upon 4. So 3a is equal to 33 upon 4, which gives you a is equal to 11 by 4. Right. Now, to find in the question was 4a, 2b, 4c. So this is 4a plus 2b plus 4c. Yeah. So this is equal to 11 minus 5 minus this answer is equal to minus 5. So you have here option B as the answer. Hope you understood this. Let's move to the next question. Question number 22. What is the value of cos 22 1 by 2 degrees? You haven't heard much of this angle, but of course, we know the double of this angle. We know cos 45 degree. That is 1 by root 2. I'll utilize the formula. There's a formula. You are aware of it. Cos 2 theta is equal to 2 cos square theta minus 1. I can write like that. So I'll utilize that formula. Here theta is equal to 20 to 1 by 2 degrees. And of course, 2 theta will be the double of that is equal to 45 degrees. So cos 45 degree is equal to 2 cos square 22 1 by 2 degrees minus 1. Cos 45 is 1 by root 2 plus 1 is equal to this. Let's take the LCM. You have 1 plus root 2 divided by root 2 whole divided by 2 is equal to cos square 22 1 by 2 degrees. This will be equal to 1 plus root 2 upon 2 root 2 whole under the root is equal to cos 22 1 by 2 degrees. So this is the answer to the question. Root of 1 plus root 2 upon 2 root 2. That is option B. So option B is the correct answer to the question. Hope you got that. Next is question number 21. Cos theta is equal to minus root 3 by 2 and sine alpha is minus 3 by 5, where theta does not lie in the third quadrant. What is the value of this given expression? Fine. Let's understand this thing first, that there are 4 quadrants. all sine, cos, cotangent, tan, everything, they are positive in this quadrant. Sine and cosecant are positive in this quadrant, and the tangent and cotangent are positive over here. Cos and secant are positive in the fourth quadrant. Okay. Also, one more thing, that cos theta lies between -1 and 1, right? This value is cos theta is minus this √3/2, which is equal to minus 1 point something around 2 something like that. See, this value is less than -1. So technically this question itself is wrong, because you can't have the cos theta value less than -1. This value is less than -1, so this question itself is wrong. But we can consider one thing, there will be a printing mistake. And if so, this cos theta can be equal to, the root is only for the upper part, that is √3/2, and not for this. So cos theta in this question is minus √3/2. If this is the value for cos theta, then we can consider there will be a solution. There is a possibility of finding the solution then, because then it will lie, cos theta will lie between -1 and 1 itself. Okay. So let's consider that cos theta is equal to -3/2, and cos square theta will be equal to 3/4. Similarly, sine alpha is -3/5, which gives you sine square alpha is equal to 9/25. And sine alpha theta will be equal to, see, that is equal to 1 minus cos square theta under the root, that is equal to plus minus 1/2. Now see, you are told that theta does not lie in the third quadrant. Cos theta was equal to a negative value. Cos is negative for second and third quadrant. So cos is negative for the second and third quadrant. It is said that the theta is not lying in the third quadrant. That means for sure theta lies in second quadrant. Okay. If theta lies in the second quadrant and the second quadrant sign is positive, I told you all are positive. Here sine and cosecant are positive. Tangent and cotangent and positive, cos and secant is positive in the fourth quadrant. Okay. So I'll only pick up the positive value of theta. So sine theta is equal to 1/2. I got cos theta, I got sine theta. Let's find out tangent of theta. So tangent of theta is sine upon cos, that is 1/2 upon cos was equal to minus √3/2. That gives you minus 1/√3. Right. So obviously you see this theta is lying in the second quadrant. So tangent of theta is got to be minus. So tangent of theta is equal to minus 1/√3. Now let's take our concentration towards alpha. We had the sine alpha, sine square alpha as this, and cos square alpha will be equal to 1 minus 9/25, which is equal to 16/25. That gives you cos alpha is equal to plus minus 4/5. Right. I'll take the negative value of it for this. See, sine is negative in the third and the fourth quadrant. So that means in the third quadrant, fourth quadrant, either the cos will be negative or the tangent will be negative. I'm taking here the cos to be a negative value. So cos is equal to minus 4/5. Let's find out the tangent now. Tangent alpha is equal to sine alpha upon cos alpha, which is equal to sine was minus 3/5. This is minus 4/5. That gives you 3/4 as the value of tangent of alpha. Okay, that's it. Now we have to find out the value of the given expression. Here it is. To find was 2 tangent alpha plus √3 tangent theta whole divided by cotangent square theta plus cos alpha. Okay, now we have all the values. We just need to fill. So 2 into, this is equal to tan of alpha is 3/4. plus root 3. Tan theta is minus 1 by root 3 whole divided by cot square theta. Cot is the inverse of cot theta is 1 by tangent of theta. So this becomes minus root 3. So minus root 3 square plus cos alpha was equal to minus 4 by 5. This becomes 3 by 2 minus 1 divided by 3 minus 4 by 5. This is 1 by 2 divided by 11 by 5. This gives you 5 upon 22. So 5 upon 22, we have option B as the answer. See, this is the only case when you have cos theta is equal to minus root 3 by 2 instead of minus root of 3 by 2. So if this correction is there, then only option B is the answer. If you have already given the cos theta is equal to minus root 3 by 2. So if this is the value, then of course, this is a wrong question. There is no answer to that. Hope you understood this. Let's move to the next question. Question number 22, if tangent of beta is equal to tan alpha plus tan gamma upon 1 plus tan alpha tan gamma, then sine 2 alpha plus sine 2 gamma plus divided by 1 plus sine 2 alpha sine 2 gamma is equal to. I'll pick this tan beta is equal to tangent alpha plus tangent gamma divided by 1 plus tangent alpha into tangent gamma. This can be written as tangent beta is equal to sine alpha. See, what will I do? Sine alpha upon cos alpha plus sine gamma upon cos gamma whole divided by 1 plus sine alpha upon cos alpha and sine gamma upon cos gamma. Let's take the LCM. So you have a sine alpha cos gamma plus sine gamma cos alpha whole divided by, see, cos alpha cos gamma and cos alpha cos gamma, from the numerator and the denominator they will cancel out, and the denominator will have cos alpha cos gamma plus sine alpha sine gamma. This is the numerator is the formula for sine alpha plus gamma, and the denominator is this formula for sine alpha minus gamma, right? So I have to find out this. Let's write this. To find was sine 2 alpha plus sine 2 gamma whole divided by 1 plus sine 2 alpha sine 2 gamma. This can be written as 2 sine alpha plus 2 gamma upon 2. This gives you alpha plus gamma cos 2 alpha minus, okay, I'll write it down, wait. Sine 2 alpha plus 2 gamma upon 2 cos 2 alpha minus 2 gamma upon 2 whole divided by 1 plus 2 sine alpha cos gamma 2 sine gamma cos alpha. Okay, so you will have it like 2 sine alpha plus gamma cos alpha minus gamma divided by 1 plus, I'll write it as such till now, sine gamma cos alpha. Okay, so now I'll change the denominator. This will be 2 sine this cos this divided by 1 plus sine alpha plus gamma plus sine alpha minus gamma multiplied by sine alpha plus gamma minus sine alpha minus gamma. Hope you understood till here. So further, this is equal to 2 sine this cos this divided by 1 plus sine square alpha plus gamma minus, see this is a plus b into a minus b form. So sine square alpha minus gamma, which will be 2 sine this cos this whole divided by sine square alpha plus gamma. So 1 minus sine square this becomes cos square alpha minus gamma. 1 minus sine square alpha minus gamma is equal to cos square alpha minus gamma. Correct? So dividing the numerator and the dividing numerator and denominator with cos alpha minus gamma, you will get 2 sine alpha plus gamma over here, and denominator will have sine square. See, I'll divide with cos square. Okay. So here you have 2 sine alpha plus gamma divided by cos alpha minus gamma. And this will be sine square alpha plus gamma divided by cos square alpha minus gamma plus 1. Now you know one thing. We solved it over here. That was equal to tangent of beta. Tangent of beta was equal to sine alpha plus gamma upon cos alpha minus gamma. Let's write it here. Tangent beta was sine alpha plus gamma upon cos alpha minus gamma. So this becomes equal to 2 tangent of beta upon 1 plus tangent square beta, which is the formula for sine 2 beta. So sine 2 beta is the correct answer to the question. Option A is the answer. Hope you understood this. Let's move to the next question then. Question number 23. If sine pi by 4 cot theta is equal to cos pi by 4 tangent of theta, then theta is equal to, fine, you have a sine pi by 4 cot theta is equal to this. Let's say this is A and that's B. So you have, let's say this is A and B. So you have sine A is equal to cos B. If you are having A plus B is equal to pi by 2, then only this is the case. A plus B is pi by 2. So then only you are having sine A is equal to cos B. That means pi by 4 tangent of theta, according to this, pi by 4 tangent of theta plus cotangent of theta is equal to pi by 2. So you have tangent theta plus cotangent of theta is equal to 2, or tan theta plus 1 upon tan theta is equal to 2, which is tan square theta minus 2 tan theta plus 1 is equal to 0, right? Yeah. So tangent square theta minus this minus 2 tangent of theta and plus 1 is equal to 0. This is the formula for tangent theta minus 1 whole square is equal to 0, which means tan of theta is equal to 1 or plus minus 1, or theta will be equal to n pi plus pi by 4. Okay. So you have option D as the answer. Hope you understood this. Next is question number 24. If x is equal to sine of 2 tan inverse 2, y is equal to cos of 2 tan inverse 3, z is secant of 3 tan inverse 4, then which of the following is the true relation between x, y, and z? You are given x is equal to sine to tangent inverse 2. So that is equal to, that can be written as 2 into 3 upon 1 plus 3 square, which is equal to 3 upon 5. Question number 24, if x is equal to sine 2 tan inverse 2, y is equal to cos 2 tan inverse 3, z is equal to secant 3 tan inverse 4, then what is the relationship between x, y, and z? Okay, first is x is equal to sine 2 tan inverse 2. So if I say 2 tan inverse x, and talking about the general formula, this is given by sine inverse of 2x upon 1 minus x square, 1 plus x square. Okay, so according to this, 2 tan inverse x sine of this is equal to sine of this. So this is equal to 2x upon 1 plus x square. So here x becomes 2 into 2 upon 1 plus 2 square, which is equal to 4 upon 5. Let's go with the second one, that is equal to y. Y is given by cos 2 tan inverse 3. Similarly, you know 2 tan inverse x formula is 1 cos inverse of 1 minus x square upon 1 plus x square. If I take the cos on both the sides, if I'm taking cos on both the sides, this will be equal to 1 minus x square upon 1x square. So here y becomes equal to 1 minus 3 square upon 1 plus 3 square, which gives me minus 8 upon 10 or minus 4 by 5. So the value of y comes out to be minus 4 by 5. Hope you're clear with the x value and the y value. X value is this and y value is minus 4 by 5. Correct. Now let's go with the z. Z is secant 3. Z is secant 3 tan inverse of 4. Okay, if I put this, tan inverse of 4 is equal to theta, which makes 4 is equal to tangent of theta. So if I'm having a right angle triangle, tan is given by perpendicular upon base. So this is the 4 1. So this is given by root of 4 square plus 1 square, that is equal to root of 17. So this is the hypotenuse. Correct. So this is it. You got hypotenuse, right? And we need to find out if this is equal to, this becomes secant 3 theta, because I have put tan inverse 4, that's equal to theta, that becomes secant 3 theta. To answer secant 3 theta, actually I need to find out cos of 3 theta, and cos of 3 theta is given by 4 cos cube theta minus 3 cos theta, and 4 into cos is based upon hypotenuse, that is 1 upon 17 root 17 cube minus 3 into 1 upon root 17, that is equal to 4 upon 17 root 17 minus 3 upon this. This makes I'll take 1 upon this 17 outside, and okay, fine, let's not do this, let's just take the LCM. So this is 17 root of 17. 4 minus 3 17s is 51. This gives me minus 47 upon 17 into root 17. This is the value of cos 3 theta. Secant 3 theta will be equal to 17 root 17 upon minus 47. So I have all the three values, right? X is equal to 4 by 5. Y is equal to minus 4 by 5 and z is equal to this. It's right. X is equal to 4 by 5. Y is minus 4 by 5 and z is equal to 17 root 17 upon minus 47. So clearly you have x as the greatest value because it's a positive value, and then is y. This is about minus 0.8, and this is the smallest value actually because this is greater than this is, if I ignore the minus sign, this is bigger value. So in case of negative numbers, y is greater than z. So this is a relationship between x, y, and z. That is the x, y, and z. This is the one. Option D. Hope you understood this question. Let's move to the next question, number 25. In a triangle ABC, medians AD and BE are drawn. If AD is equal to 4 and DAB is pi by 6, ABE is pi by 3, then you have to calculate the area of triangle ABC. Okay. Let's draw the triangle first to understand the problem. So if I say this is a triangle, let's say this is the triangle. Here is A, B, and C. AD and BE are drawn, medians AD. So let's draw the median AD first. This and BE. This is second median. Okay, just give me a minute. Fine. So this is BE, this is the median. AD is 4, this is 4, and angle DAB is pi by 6, angle ABE pi by 3. Then you have to find out the area of triangle ABC. Question number 25. In a triangle ABD, medians AD, BE are drawn. AD is 4, DAB is pi by 6, AB is pi by 3. Then you have to find out area of the triangle ABC. Let's draw that triangle. So let's make a bigger one. This is the triangle ABC. And let's draw the two medians. Here you have AD. That means BD is equal to DC. Also you have BE. So this means AE is equal to EC as well. Now you are given that angle DAB is pi by 6. This angle is pi by 6. This angle is pi by 3. So you have angle DAB plus ABE plus angle, if I say this point as G, the point of intersection of the two medians, angle AGB is equal to pi. This gives angle AGB is equal to pi minus pi by 6 minus pi by 3, which is pi by 2. So this is a 90-degree angle. Okay, though it doesn't look like, but it is a 90-degree angle. Correct. So now G is the point where the two medians are meeting. So G is the centroid of the triangle. Since G is the centroid of the triangle and you have BD is equal to DC, so G divides AD. You are given AD is equal to 4. G divides AD in the ratio of 2:1. So you have AG is equal to, what will we see? This is 2:1. So the whole length of this is 4. So AG will become 4 into 2 upon 2 plus 1. And you have the second one, DG. This is equal to 1 into 4 into 1. Sorry. This is equal to 1 into 4 or 4 into 1 upon 2 plus 1. This is 4 by 3 and this is 8 by 3. So you have AG as 8 by 3 and DG as 4 by 3. Now in triangle ABG, you have tangent of pi by 3 is given by the base upon, perpendicular upon base, that is AG upon BG. So this is equal to BG. This gives you BG is equal to AG into 1 upon tan, that is equal to cotangent of pi by 3. So BG becomes AG is 8 by 3 and cot of pi by 3, that is equal to this. This is equal to 8 upon 3 root 3. Now you got the BG as, see, this is 8 by 3 and this one is 4 by 3. You got the BG as 8 upon 3 root 3. Now the area of the triangle ADB, area of triangle ADB is equal to half into base into height, right? So this is equal to half into AD is 4. It's given. BG we just calculated 3 upon 3 root 3. So this is equal to 16 upon 3 root 3. This is area of the triangle ADB. Now the median divides the triangle in two triangles of equal area. You know that. Median divides a triangle into two triangles of equal area. So therefore, area of triangle ABC is twice area of the triangle ADB. So area of triangle this is equal to 2 into 16 upon 3 root 3, which is equal to 32 upon 3 root 3 square units. So this is the answer to the question, 32 upon 3 root 3. That is option C. Hope you understood this. Let's move to the next question then. Question number 26, in a triangle ABC, 2 delta square is equal to A square, B square, C square upon A square plus B square plus C square. Then the triangle is equilateral, isosceles, right angled or acute angle. So you are given 2 delta square is this upon A square plus B square plus C square, or A square plus B square plus C square is equal to ABC upon delta. This whole is under the square into 1 by 2. Now this is, you know one thing, ABC upon delta is equal to 4R, where R is the circumradius. So this is equal to 4R square, which is the 4 into R into 4 into R divided by 2. This gives you 8R square. Correct. Now you know also one thing, that A is equal to 2R sin A, B is equal to 2R sin B, and C is 2R sin C. This gives you, so if I fill in all these values in this given equation, you will get 4R square sin square A plus, see, I'm taking 4R square, like when I'm squaring them, so 4R square I have taken outside, and inside we'll have sin square A sin square B sin square C is equal to, that was equal to 8R square, or you have a sin square A plus B plus C is equal to 2. Right now, this, see, you know also one more thing, that cos 2A is equal to 1 minus 2 sin square A. So let's multiply first of all both the sides by 2. Okay, so you have 2 sin square A plus 2 sin square B, 2 sin square C is equal to 4. So here I can say 2 sin square A is equal to 1 minus cos 2A. This becomes 1 minus cos 2A plus 1 minus cos 2B plus 1 minus cos 2C is equal to 4, which gives you cos 2A, 2B, 2C is equal to minus 1. I think this is clear to you, right? Now, one more thing, here you have a formula that cos 2A plus cos 2B plus cos 2C. This is equal to, this is one of the identities, minus 1 minus 4 cos A cos B cos C. This is equal to minus 1. So cos 2A plus cos 2B plus cos 2C is equal to minus 1 minus 4 into cos A cos B cos C. This will give you minus 4 cos A cos B cos C is equal to 0, or just cos A cos B cos C is equal to 0, right? I hope you are clear here. So on anyone among A, B, C has to be pi by 2. Then only This is going to be 0. This whole expression will be 0 only if either A or B or C is equal to pi by 2, right? So even if one of the triangles is a 90 degree, so it is a right angle triangle, right? I hope you're clear with this. Either, I'll write here, either A or B or C is equal to 90 degree for this expression to be equal to 0. So this is 90 degree. That means this is a right angle triangle. Option C is the answer to the question. Hope you got that. Next is question number 27. Sides of the triangle inscribed in a given circle. Subtend alpha, beta, gamma at the center. Minimum value of the arithmetic mean of cos alpha plus pi by 2, cos beta plus pi by 2, cos gamma plus pi by 2 is equal to. First of all, we'll simplify the angles, right? This is cos alpha plus pi by 2 or cos pi by 2 plus alpha. This is equal to sine minus sine alpha. Cos beta plus pi by 2. This is minus sine beta. Cos gamma plus pi by 2. This is minus sine gamma. Now you're given the side inscribed in the given circle. Subtend this angle at the center. Minimum value of AM. Fine. You know one thing, that arithmetic mean is always greater than or equal to geometric mean. So let's find the arithmetic mean of them. You have minus, I'll take it common, sine alpha, sine beta, sine gamma divided by 3 is greater than equal to GM. GM is given by minus sine alpha, sine beta, sine gamma raised to power 1 by 3. So equating them, we hold, if I'll equate them, this will be question number 27. The sides of the triangle inscribed in a given circle. Subtend angle alpha, beta, gamma at the center. Minimum value of the arithmetic mean of cos alpha plus pi by 2, cos beta plus pi by 2, cos gamma plus pi by 2 is equal to. Let's consider these three angles first. Cos alpha plus pi by 2, that's equal to minus sine alpha. This is equal to minus sine beta, and this is equal to minus sine gamma. So, you know one thing, arithmetic mean is always greater than equal to geometric mean, which means minus sine alpha plus sine beta. I'm taking the minus common, divided by 3 is greater than minus sine alpha into minus sine beta into minus sine gamma. That will be only 1 minus. So that is equal to 1 raised to power 3. So this equating holds when all the three are equal. Equating holds when alpha is equal to beta is equal to gamma, or alpha plus beta plus gamma is equal to 360 degree. When the three are equal, then that means these three will be equal to 120 degree each. So the arithmetic mean becomes 1 by 3 cos of sine of wait, yeah, I'll take minus outsides, right? So this is sine of 120 degree plus sine of 120 degree plus sine of 120 degree, right? I'm taking 3 outside, so this is minus 1 sine 120 degree, which can be written as minus 1 sine 180 minus 60 degree. That is equal to minus 1 into sine 60 degree, or that is equal to minus root 3 by 2. So this is answer to the question, minus root 3 by 2, option B. Hope you got that. Next is question number 28. The position vectors of the point A, B with respect to 0 are this and this. The length of the internal bisector of angle BOA of triangle AOB is dash, taking proportionality constant equal to 2. So here you have this triangle ABC. Okay, no, AB, and let's say this 0. So this is O point, which is the origin 0, 0, 0. This is the point A, 2, 2, 1. And this is the point B, which is having the direction ratios as 2, 4, and 4. The position vector of this is with respect to O are this and this. The length of the internal bisector of BOA. So this internal bisector of this angle is, you have to find out the length of this. So if I'm saying this OD, you have to find out the length of OD to find OD, right? First of all, if I find AO is given by root of 2 square plus 2 square, CAO, 2 minus 0 square, to better write it as 2 minus 0 square plus, or wait, this is equal to 0 minus 2 square plus 0 minus 2 square plus 0 minus 1 square, which is equal to 4, 4, and 1, that is equal to 3. Similarly, OB will be given by root of 0 minus 2 square, 0 minus 4 square, 0 minus 4 square, which is equal to root of 4, 16, and 16, which is equal to root of 36. That means this is equal to 6. Now, by the angle bisector theorem, you have AO upon BO is equal to AD upon BD is equal to 3 by 6, which gives you the D coordinates as, so D will be given by, this is 2:1. Correct. So by using the section formula, D will be having the two coordinates as 2, 2, 1 plus 1 into 2, 4, 4 whole divided by 2 plus 1. This is equal to 4, 4, 2 plus 2, 4, 4. So that's equal to 6, 8, 6 divided by 3, right? Or that is 2, 8 by 3, 2. So this is these are the coordinates of D. O is 0, 0, 0. You have to find out OD. This is given by 2 minus 0 square, 8 upon 3 minus 0 square, 2 minus 0 square. That is root of 4 plus 64 upon 9 plus 4. This gives you root of 136 upon 3. So this is the answer to the question, root of 136 upon 3, option B. Hope you got that. Next is question number 29. Let U be 2I plus 3J plus K, V be this, W be this. Then which of the following statements is true? U is perpendicular to V but not W. V is perpendicular to W but not U. W is perpendicular to U but not V. Or U is perpendicular to both V and W. Fine. You are given U is, let's write 2I plus 3J plus K and V minus 3I plus 2J. W is I minus J plus 4K. So what are the direction ratios for U? It is 2, 3, 1. V is minus 3, 2, 0. And W is 1, minus 1, and 4. You have to find out, let's find out the dot product of the two, U and V. This is given by dot product of U and V will be given by 2 into minus 3, that is minus 6. 3 into 2 plus 6 and 1 into 0, that is 0. So this is equal to 0. Dot product of U and W, this is 2 into 1, 3 into minus 1. So this is minus 3. And 1 into 4, this is equal to 4. So this comes out to be 5, right? No, sorry. This is minus 1 plus this. This is equal to 3. Fine. And 3, this is not equal to 0. Therefore, U is, they are perpendicular. U is perpendicular to V, but U is not perpendicular to W. That's it. we have option A. U is perpendicular to V but not to W, which means option A is the correct answer. Hope you got that. Next is question number 30. If the lines x minus 3 upon 2, y minus 2 upon 3, z minus 1 upon lambda, and these set of lines are coplanar, then sine inverse of sine lambda plus cos inverse of cos lambda is equal to. So, we are given that these two lines are coplanar. If the two lines are coplanar, if two lines are coplanar, then x minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. So now the given lines are L1 is given by x minus 3 upon 2, y minus 2 upon 3, z minus 1 upon lambda. Therefore, here you have x1 is equal to 3, y1 is 2, and z1 is equal to 1. A1 is 2, b1 3, and c1 is equal to lambda. Let's go for the line L2. You have given x minus 2 upon 3 is equal to y minus 3 upon 2 is equal to z minus 2 upon 3. So here you have the same things, but A2 is equal to 3, B2 is 2, and C2 is 3 again. So from equation 1, which is, let's say this one, from equation 1, let's fill in the values. See here you have x2, the same thing. X2 was equal to 2 and Y2 was equal to 3 and Z2 was equal to 2. So this equation from equation 1, let's fill in the values. You have x1, 3 and x2 as 2. So this becomes 2 minus 3. Here is 3 minus 2. Here is 2 minus lambda. Wait, it was 1, sorry. And A1, A2, A3, this is 2, 3 lambda, and this is 3, 2, 3. This has got to be 0. This will become minus 1, 1, 1, 2, 3 lambda, and 3, 2, 3. This is equal to 0. Let's do some operations. I will do C2 as C2 plus C1 and C3 as C3 plus C1. This will become minus 1, 2, 3. So this is 0. 3 plus 2, this is 5. 5, 0, lambda plus 2, 3 plus 3, that is equal to 6. This is equal to 0. So let's expand it along the column. This minus 1, first row, first column. So minus 1 is equal to 5 into 6, that's 30, minus 5 into lambda plus 2 is equal to 0, which gives you 30 is equal to 5 into lambda plus 2, or 6 is equal to lambda plus 2, which gives you lambda is equal to 4. That's it. We got the value of lambda, right? And we have to find out sine inverse of sine lambda and the cos inverse of cos lambda. To find was sine inverse sine lambda. So I'm writing directly 4 cos inverse cos lambda, that is equal to 4 again. So this is sine inverse sine 4 is equal to pi minus 4 plus 2 pi minus 4. Now how is that? You can write that as sine inverse sine pi minus 4. See, directly you could have written this as 4 and this as 4, but 8 is not in the options, but rather the options contain the pi factor also. So I have to convert this into the pi form. So this can be written as sine inverse sine pi by 4 plus cos inverse cos pi See, this is 2 pi minus 4, because in the second quadrant sine is positive, and in the fourth quadrant cos is positive. So I will take these two values. Okay, this gives me pi by 4 plus 2 pi minus 4. I hope you got this. Cos inverse cos, sine inverse sine, they will cancel out. Okay, so this becomes 3 pi minus 8. This is the answer to the question. Let's check. 3 pi minus 8 is option C. Hope you understood this. Let's move to the next question, number 31. If A is given by this vector and B is given by this, then unit vector in the plane A and B perpendicular to A is, we are given A is 1, 1, 0, and B is 1, 1, and 1. So if I say the unit vector in the plane of A and B vector will be given by A plus lambda B. So, and plane of A and B and perpendicular to A vector is given by A plus lambda B dot A. This dot product should be equal to 0 if they are perpendicular to each other. So this gives you, let's write it properly, A plus lambda B into dot product of A is equal to 0. This gives you A dot A plus lambda A dot B is equal to 0. What is A vector was equal to? That's 1, 1, 0. Let's write it here. So A was 1, 1, 0. B was 1, 1, 1. So A dot A is gonna give you 1 into 1 plus 1 into 1 plus 0 plus lambda will be taken outside. A into B, this is 1 into 1, 1 plus 1 into 1, 1 plus 1 into 0, 0. This is equal to 0. This gives me 2 plus 2 lambda is equal to 0, or lambda is equal to minus 1. Therefore, the C, which is the perpendicular, the vector which is perpendicular to the plane AB and, vector in the plane AB and perpendicular to the A vector is given by, that was equal to A plus lambda B, right? So A, that becomes A was 1, 1, 0 plus minus 1, 1, 1, 1, which is equal to 1, 1, 0 plus minus 1, minus 1, minus 1, that is equal to, that is equal to 8. Yeah. So that is equal to question number 31. If A is given by this vector and B is given by this vector, then the unit vector in the plane A and B and perpendicular to A vector is given by. So here A has the direction ratios 1, 1, 0. B has 1, 1, 1. And vector in the plane of A and B, vector in the plane of A and B is given by A plus lambda B. Now, and perpendicular to A vector, this will be the dot product of the two. If they are perpendicular, therefore the dot product of the two will be equal to 0, which gives you A dot A plus lambda into B dot A is equal to 0. A dot A vector was 1, 1, 0. B was 1, 1, 1. So this is equal to 1 into 1 plus 1 into 1 plus 0 into 0 plus lambda into 1 plus 1 plus 0 is equal to 0. This gives you lambda is equal to minus 1, right? Therefore, the plane is, that was equal to A plus lambda B. So that is 1, 1, 1 plus minus 1, 1, 1, 1. This gives you 1. Okay, let's write it like this first. Minus 1, minus 1, minus 1. This is equal to 0, 0 minus 1, or that can be given by minus of k unit vector. So here the option C should be minus. Option C is the correct answer. Hope you understood. Next is question number 32. The line passing through this and parallel to this vector meets the line this at A and the plane this at B. You have to find out the length of A and B. Fine. So over here, the direction ratios are 1, 2, minus 1. Therefore, the line passing, according to the question, line passing through 1, 1, minus 1 and parallel to the vector this is given by x minus 1 upon 1 is equal to y minus 1 upon 2 is equal to z plus 1 upon minus 1. That is equal to lambda. See, that's equal to some lambda. And the line L2, it's given in the question. This is the one, x minus 3 upon minus 1, y plus 2 upon 5, z minus 2 upon minus 4 is equal to, let's say this is equal to some mu. Now for point A, lambda plus 1, if I'm saying using this lambda plus 1, 2 lambda, I'm using this 2 lambda plus 1, and then I'm using this minus lambda minus 1 is equivalent to, from here, minus mu minus 3, from the minus mu plus 3, sorry. And from this, I have 5 mu minus 2. From this, I have minus 4 mu plus 2. This gives you, from the 1, you have lambda plus 1 is equal to minus mu plus 3, which gives you lambda is equal to minus mu plus 2. Or lambda plus mu is equal to 2. And from the second, you have 2 lambda plus 1 is 5 mu minus 2. So 2 lambda minus 5 mu is equal to minus 3. Fine. Let's fill in this one. So this lambda is equal to 2 minus mu. So 2 into 2 minus mu minus 5 mu is equal to 3, which gives you 4 minus 7 mu is equal to 3, or minus 7 mu is equal to minus 1, which gives you mu as equal to I forgot to put this minus. This is minus, so this is 7. So mu comes out to be 1. Okay, if mu is equal to 1, from here, lambda is also equal to 1. So we got both the values for mu is equal to 1 and lambda is equal to 1. Therefore, the point A, this point A becomes A, which was equivalent to lambda plus 1, 2 lambda plus 1, and minus lambda minus 1. Now this is equal to 2, 3, and minus 2. That's a point A. Now let's go for this plane P, which is 2x minus, plane P is given by 2x minus y plus 2z plus 7 is equal to 0. So let's put these values, x as lambda plus 1 minus 2 lambda plus 1 plus minus 2 lambda minus 2 plus 7 is equal to 0. This gives you minus 2 lambda plus 6 is equal to 0, or lambda is equal to 3. So B will have the coordinates as, if I'm putting the values for the lambda, then B will have the coordinates as x will be this lambda plus 1. This is y. So this has got to be 7. And this is z, which is got to be minus 4. We got the coordinates of A and B. Let's write them once again. So A had the coordinates as 2, 3, minus 2. B had the coordinates as 4, 7, minus 4. AB will be given by using the distance formula. You will have 4 minus 2, which is equal to 2 square, 7 minus 3, that is 4 square, minus 4 plus 2, that is minus 2 square, which is 4 plus 16 plus 4, which is root of 24, or that is given by this 2 root 6, which is option B. So option B is your correct answer. Hope you got that. Next is question number 33. Let A be this vector, B be this vector. The point of intersection of these lines and these is given by. Here you are given that A is equal to I vector, unit vector, and B is J unit vector. R cross A is equal to B cross A, which gives you R cross A minus B cross A is equal to 0, or you can, you also have here you can say R minus B into A is equal to 0, which gives you R minus B is equal to some lambda A, or R is equal to B plus lambda A. So B was equal to your J, and this was equal to your lambda into I. This can be written as lambda I plus J. Next, R into B, the second one was R into B was equal to A into B, which makes R into B minus A into B is equal to 0. R minus A cross, actually, this is equal to 0. This gives you R is equal to A plus, let's say, mu B. So this is equal to I plus mu J. So let's say this is 2 and let's say this is 1. Comparing 1 and 2. Comparing 1 and 2, you have lambda I plus J is equal to I plus mu J. This gives you, if I do the comparison, this gives you lambda is equal to 1 and mu also equal to 1. You got the two values for lambda and mu. So R was equal to I plus J. That's it. This is the value of the question. Option A is the correct answer. Hope you got that. Next is question number 34. The mean deviation from the mean of the set of deviations. This is actually pretty easy question. First of all, let's find out the mean for this. Mean is given by -1 plus this upon 4, which is equal to 1. And deviations, let's see. Deviations are -1, 1. So deviation is this. And the second deviation is 0 minus 1. Third deviation is 4 minus 1. So this is equal to 2. The deviation is 2, 0, and 3. These are the deviations. Mean of the deviations is this. That is equal to, sorry, this is 1. Sorry, not 0. So this is equal to 2. That's it. You have to find out the mean deviation. That is option D. Hope you got that. Next is question number 35. Let an angle of triangle is 60 degrees. The variance of the angles of the triangle is 1014 degrees. Okay. Then the other two angles are fine. We are given variance of the angles is this. So, variance is given by summation of xi square upon n minus summation of xi upon n whole square. And this is given to you as 1014, right? Angle of the triangle is equal to 60 degree. Therefore, you have summation xi square. So first of all, it will be 60 square for the first angle. Let the two other angles be A and B. So plus A square plus B square upon n, which is 3, minus xi upon n whole square. So this is equal to 60 square. Correct. Then this is 1014. That gives you, I'll take 60 square. Okay, this is 60 square upon 3 plus this is equal to 1014 plus 60 square, which is equal to 3600. This gives you, okay, I'll add all of them. First of all, I'll leave it like this only. So this is equal to 16 to, this is 20 into 60, that is equal to 1200 plus this. Here was square, sorry, not cube. I don't know how I started writing cube. Okay, so here you have, this is A square plus B square upon 3 is equal to 1014 plus 3600 minus 1200. That is equal to 1014 plus 2400, which is equal to Question number 35. Let an angle of the triangle is 60 degree. If the variance of the angles of the triangle is 1014, then the other two angles are. Fine. Let's just write down the formula first of all for the variance that is given by summation xi square upon n minus summation xi upon n whole square. Okay. Now the variance is given to be 1000. Sorry, 1014. So summation of xi square upon n. So first angle is 60. So that is 60 square. Let the other two angles be A and B. So this will be 60 square plus A square plus B square. The angles are 3. So this is equal. I'll write 3 in the denominator. Minus summation xi upon n. Now what is that? This is summation xi upon n. So first angle plus second angle plus third angle upon n, that is 3. See, the total of the three angles, that is equal to 180. So this is got to be 60. Okay, so this is 60 square. Hope you got this. Next, let's solve it. You will write it as 1014 minus this will be plus 60 square is equal to, this is multiplied by P is equal to 60 square plus A square plus B square. So this is 3 into 3600 plus 1014, that is equal to 4614 is equal to 3600 plus A square this. Let's multiply this with 3 now. You have 12, 4, 18 and 13. And let's subtract 3600. So you will have 10242. Okay. So this is giving you 13842 is equal to 3600 plus A square plus B square, or 10242 is equal to A square plus B square, right? Now you also know the other two angles that are equal to 120 degree. Because one angle is 60 degrees, so the sum of other two angles is equal to 120 degree. So you have A plus B is 120 and A square plus B square is equal to 10242. Let's do the squaring on both the sides. You will have here A square plus B square plus 2AB is equal to 14400, or that is 2AB is 14400 minus this. This will give you 8, 5, 1 and 4. So let's divide it with 2. You will have 2, 0, 7 and 9. That is the product of AB. So you have AB is equal to 120 and A plus B is equal to 120 and AB is equal to 2079. You can definitely find out the value of A. So when you will solve, you will get A's value as 21 and B as 99. That's it. You have option C as the answer. Hope you understood this. Next is question number 36. One card is selected at random from 27 cards numbered from 1 to 27. What is the probability that the number on the card is even or divisible by 5? So let's write down first of all the cards which are even and divisible by 5. Let's write down those. Sorry, it's or, not and. So here I shall write down or. That makes a huge difference. First even number is 2. Then you have 4, 5 is divisible by 5. Then you have 6, 8, 10, 12, 14, 15, 16, 18, 20, 22, 24, 25, 26. That's it. So these are the numbers. And you have to find out the number, the probability that the number is fine, number of even or divisible by 5 cards. You have to find out the number of the cards, probability that the card is even or divisible by 5. So number of cards which are even or divisible by 5 is given by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you have 16 such cards over here. Required, and the total cards are 27. So NS is 27. Let's say this is equal to N of A. That is the required number of cards. Now you have to find out the probability. Required probability is equal to number of required cards upon the number of total cards, which is 16 upon 27. That's it. You have 16 upon 27, option B as the answer. Hope you understood. Next is question number 37. 9 balls are drawn simultaneously from a bag containing 5 white and 7 black balls. Probability of withdrawing 3 white and 6 white balls is, 3 white and 6 black balls is. So you have 5 total, 5 white balls and 7 black balls. So you have to withdraw 3 white to withdraw 3 white and 6 black balls, right? So out of 5, how can the 3 white balls be taken out? It can be done in 5C3 ways, and out of 7, 6 black balls can be taken out in 7C6 ways. What the total number of balls? Total balls are 12. So you have 12 balls over here. And how many balls you want to withdraw? That is 9. Fine. So required probability is equal to, from here, 5C3 multiply 7C6 whole divided by, from the total balls, you have to, total balls were 12, and total, from the total balls, you have to withdraw 9 balls. So that is 12C9. So here you have 5 factorial divided by 3 factorial upon 2 factorial multiply 7 factorial, 6 factorial into 1 factorial, whole divided by 12 upon 9 factorial into 3 factorial. Fine. So let's write, you have this as 5 into 4 upon 2, 7 upon 1. I hope you know this, right? 7 factorial, 7 into 6 upon 6 factorial. This will give you 7. And this will be given by 12 into 11 into 10 upon 3. So this is equal to 70 upon, this is 440. That is, you have give me a minute. Sorry, I missed this 3 over here. 3 into 2. Sorry, this 2 I forgot to write down. 3 into 2. So this will cancel and this will be 2. So this will be 220, or 7 upon 22 is the required answer. That is option B. Hope you understood. Next is question number 38. The probabilities that A and B speak truth are 4 by 5 and 3 by 4 respectively. Probability that they contradict each other when asked to speak on a fact is what? Fine. See, they will contradict each other in 2 cases. Let's write. They will contradict in 2 cases. First case is when A is speaking truth and B is saying false, or when A is saying false and B is saying truth. Okay, or true. Fine. So the required probability, see, in this case, when A, how many of the chances A will be speaking truth is 4 by 5, and A is speaking false is 1 by 5. B is talking truth is 3 by 4, and false is 1 by 4. So required probability becomes, see, when A is speaking truth and B is speaking false, this will be given by 4 by 5 into 1 by 4, or when A is speaking false and B is speaking truth, so this is 1 by 5 into 3 by 4. That's it. You have this 1 by 5 plus 3 by 20. that is equal to 20 upon 4 plus 3 or 7 upon 20. 7 upon 20, this is the correct answer. Option D is the answer. Hope you got that. Next is question number 39. The mean and variance of a binomial variable x are 2 and 1 respectively. The probability that x takes values greater than 1 is. Okay, let's write down. You have the mean formula as n into p, and variance is n into p into q. Variance is n into p into q. So you are given that the mean is 2 and the variance is equal to 1. So see over here, wait, mean and variance are 1, 2 and 1 respectively. Probability that x takes value greater than 1 is. Question number 39. The mean and variance of a binomial variable x are 2 and 1 respectively. Probability that x takes a value greater than 1 is. Fine, you are given mean, which is mean is given by actually n into p. The formula is n into p. This is 2 and variance is npq. That is equal to 1. This implies that q, the question q is equal to 1 by 2. If q is equal to 1 by 2, then p is also equal to 1 by 2 because p is 1 minus q, right? So that's it. What from here I can calculate n as n into p was 2. So n into 1 by 2 was 2, which gives me n is equal to 4. So now the probability that x is greater than 1 is equal to the probability that x is equal to 2, x is equal to 3, x is equal to 4 because n is equal to 4. So this is the probability over here will be given by 4c2 plus 4c3 plus 4c4. 4c2 is equal to 4 into 3 upon 2 plus this is 4 and this is 1. And that is 6 plus 4 plus 1, which is equal to 11. Okay, one thing, I have to multiply the whole thing by 1 upon 2 raised to power 4. This is also there. So this becomes equal to 11 upon 16. You have option C as the answer. Hope you understood this. Next is question number 40. For the random variable x with the probability distribution, which is given by this question, what is the mean of x equal to? Fine. So you have summation p, wait. You have summation probability x is equal to r, that is equal to 1. You know this thing, right? The sum of the probabilities that is equal to 1. So that means k plus this plus this plus this is equal to 1. So k plus 1 by 7 plus 2k plus 2 by 5 is equal to 1, which gives me 4k plus 12, and this will be 5 into 14, 5 plus 14, that is 19 upon 12 is equal to 1. 4k is equal to 1 minus 19 upon 12. That will give you, wait. Sorry, this is not 12. I have just added. I have done a mistake. Wait. So you have 1 by 5, 1 by 7, 2 by 5, that is equal to 1. 4k plus 35, 5 plus 14 is equal to 1, or 4k is equal to 1 minus 19 upon 35, which gives you 13 minus 19 is 35 minus 19 gives you 16. Right. Yeah. So that is 16 upon this, or k will be equal to 4 upon 35. That is the value of k. Now, what is the mean of x? This is what we needed to find out. So mean is, that is mu is equal to summation pi xi divided by summation of pi. That is equal to summation pi xi, right? Because summation of pi is equal to 1. And here this is, let's solve this. So summation pi xi, this is equal to k into 0 plus k plus 1 by 7 into 1. That is k multiplies 0 plus this 2k into k, 2k into 2 and 2 by 5 into 3. Okay, so this is what you have as 0 plus k by 7, 4k, 6k by 5k was equal to 4 by 35. So you have 4 upon 35 into 1 by 7 plus 4 into 4 by 35 plus 6 by 5, which will be equal to, this will be equal to 4 by 35 into 8 by 7 plus 6 by 5. And here you have, let's take the LCM. Question number 40, for the random variable x with the probability distribution is given by this table. You have to find out the mean of x. So this is the probability distribution table. You know one thing, summation of p when x is equal to r is always equal to 1, which means the sum of these values is equal to 1, k plus 1 by 7 plus 2k plus 2 by 5 is equal to 0, is equal to 1. So this is going to give me 4k plus, I'll take the LCM 35, 5 plus 14 is equal to 1, or 4k is equal to 1 minus 19 upon 35, which is 16 upon 35. Here you will get the value of k as 4 upon 35. Right, we have to find out the mu, that is mean. So that is given by summation pi xi upon summation pi. This is equal to summation pi xi upon 1. So that is given by summation pi into xi, that is k into 0 plus 1 into k plus 1 by 7 plus 2 into 2k plus 3 into 2 by 5. That is equal to k plus 1 by 7 plus 4k plus 6 by 5. This is gonna give me 5k plus 35, and this is 5 plus 42. 5k was equal to this, so this is 47 upon 35. You have 35, so this becomes 67. So 67 upon 35 is the answer. That is option D. Hope you got that. Next is question number 41. The locus of a point which is at a distance of 4 units from this in xy plane is. We have to find the locus of the point which is at a distance of 4 units from this point in the xy plane. All right. So let that point be HK. Let point be HK. So according to the question, h minus 3 square, k minus minus 2, that is plus 2 square is equal to 4 square, which gives me x square plus 9 minus 6h plus k square plus 4 plus 4k is equal to 16, or h square plus k square minus 6h plus 4k minus 3 is equal to 0. If I replace the h by x and k by y, you will have the equation as x square plus y square minus 6x plus 4y minus 3 is equal to 0. So this is your option D. So this is the correct answer to the question. Hope you got that. Next is question number 42. Before starting with this question, students, as a quick reminder to visit our website www.examsnet.com. There you will find this and many more similar type of entrance exam question papers for your practice. You can also download our app. The link is available in the description box. You must explore our website for your benefit. So let's start with question number 42. It says when the axes are rotated through an angle of 45 degree, the new coordinates of a point P are 1, minus 1. The coordinates of P in the original system are what? Okay, if I say the initial coordinates, if initial coordinates of any point xy and after rotation, coordinates x and y, then you have x is equal to x cos theta, y sin theta, and y is equal to x sin theta plus y cos theta. Here we have theta is 45 degree, x is equal to 1, y is equal to -1. So you have 1 is equal to, not 1, sorry, small x is equal to 1 into cos 45 minus of -1. This is +1. This is multiply. 1 multiply sine 45 degree. And similarly, y is equal to 1 into sine 45 plus 1 into cos 45 degree. So this is equal to 1 by root 2 plus 1 by root 2. And this is also equal to the same. That is, you have 2 upon root 2 or root 2. See, sorry, there's one mistake here. The y was this. So here's y negative. You are having, wait. Yeah, here the y was negative. So this is -1 and this will be -1 upon this. This is 0 and this is equal to 2 upon root 2, which is equal to root 2 only. So the coordinates are root 2 comma 0. Hope you understood this. We have option B as the answer. Right? Next is question number 43. Find the equation of the straight line which is passing through this and cutting off equal intercepts of the coordinate axis. Fine. So first of all, equation of the intercept form. You know that equation of line intercept form is given by x upon a plus y upon b is equal to 1. Now, if it passes through this, if line passes through this point, then you have -5 upon a, 6 upon a is equal to 1. Now, why? Because here b is equal to a, right? Because it is cutting off equal intercepts on the coordinate axis. Therefore, these are the equal intercepts, right? B is the y-intercept and A is the x-intercept. So they both are equal. Now this gives you 1 upon A is equal to 1, or you get A as 1. So what does the equation of the line becomes? X plus y is equal to 1. That is option D. Hope you got that. Next is question number 44. Line has slope m and y intercept as 4. Distance between the origin and the line is equal to. Okay, we are talking about the slope thing, right? So the equation of the line can be written like this: mx plus c, where m is the slope and c is the intercept of y-intercept. So this can be written as y is equal to mx plus 4. Now, distance of this line from origin. Distance from origin will be given by m into 0 plus minus 0 plus 0, 4. Sorry for this. I'll write it again. So this can be written as y is equal to mx, and then this is m into 0, or you can write it like mx minus y plus 4 is equal to 0. So this is m into 0 minus 0 into 1. So minus 0 plus 4 whole divided by 1 root of m square plus minus 1 square, which is equal to 4 upon root of 1 plus m square. That is it. Distance is this. Option D is the answer. No, not D. It is C. Right? Hope you understood. Next is 45th question. The equation of the base of an equilateral triangle is this. One vertex is this. Length of the side of the triangle is. Okay, you are given that the base is this. This is a triangle. So the base is given by x plus y is equal to 2. Now the vertex is this 2, 1. Clearly, if I put this point in this line, that is 2 minus 1 in x plus y is equal to 2, you have 2 minus 1. This is not equal to 2. So clearly this point does not lie on this line. This is this point only. Okay. So we are confirmed that this is point A and this is this line. This is an equilateral triangle ABC. Now I have to find, I have the formula to find out the perpendicular distance from A and perpendicular distance from A on BC. Perpendicular distance from A on BC will be given by D is equal to, so if I'm taking that D or let it be AD is equal to mod of 2 into 1. See, this was the point 2 minus 1. So 2 into 1, 2, 1 into minus 1, minus 2 whole divided by root of 1 square plus 1 square, which is equal to 1 upon root of 2. Now this is AD. We have to find out AB. Know one thing, when we are having an equilateral triangle, I hope you are aware of this formula. So if this is the height and this is the side by 2, the perpendicular dropped from the vertex, actually bisects the third side, opposite side. So here, this A will be given by 2 by 3h. This is the formula. Must remember this formula because we'll be using this in this question. So AB is equal to 2 by root 3 into AD, or this is equal to 2 by root 3 into this. And this is equal to this root 2 by 3. That's it. We have option C as the answer. Hope you understood. Next is question number 46. Equation of a straight line which passes through this point and perpendicular to this is given by. Okay. So equation of a straight line which is passing through this and perpendicular to this. Fine. So if the slope of the, let's say the slope of the required line, slope of required line is equal to m, let's say this, then m into minus secant theta upon cosec theta is equal to minus 1, or this is equal to, this gives you m is equal to minus cosec, minus actually will cancel, so I'll have cosec theta upon secant theta, which gives me nothing but the cotangent of theta. Okay, because this will be cos theta upon sin theta, so this will be equal to cotangent theta. Okay, now I hope you got this thing, like how I did this. See, m into minus secant theta upon cosecant theta was like, here you can write this equation as y is equal to y cosec. I'll restart the home serve. Question number 46, equation of the straight line which is passing through this point and perpendicular to this line is equal to what? If I talk about this line, x secant theta, y cosecant theta is equal to a, which gives me y cosecant theta is equal to x secant theta plus a, minus will be here, and y will be given by minus secant theta upon cosecant theta x plus a. So this is the slope of this line, right? Let the slope of this straight line, which is talking about, let slope of required line be m. Now, you know, if the two lines are perpendicular, the product of their slopes is equal to minus 1. According to that, according to question, m into minus secant theta upon cosecant theta is equal to minus 1. This gives me m is equal to cosecant theta upon secant theta, or that is equal to cotangent of theta. Now the line passes through this point. It is given line is passing through this point. So the equation of the line will be given by y minus a sine cube theta is equal to m, that is cot theta, x minus a cos cube theta. This gives me y is equal to x cot theta minus a cot theta cos cube theta a sine cube theta, or y sine theta is equal to x cos theta. I'll take a common, cos raised to power 4 theta minus sine raised to power 4 theta. I'm multiplying both the sides by sine. So this will be there. See, multiplying both the sides by sine theta. Okay. So then you have y sine theta is equal to x cos theta minus a cos square theta plus sine square theta into cos square theta minus sine square theta. This is equal to 1. So you have y is equal, y sine theta is equal to x cos theta minus a cos square theta minus sine square theta, or you have x cos theta minus y sine theta is equal to a cos 2 theta. This is equal to cos 2 theta. So this is the required equation of the line. Option B is the answer. Hope you got that. Next is question number 47. Acute angle between the lines y 6x squared plus 11y xy minus 10y squared is equal to 0 is. Given line 6x squared 11xy minus 10y squared is equal to 0. This is the line. Let's split the middle term. You will have the two factors as this is 60 unit, right? So the two factors will be given by 15xy minus 4xy minus 10y square is equal to 0. I have 3x common, 2x plus 5y minus 2y, 2x plus 5y. So the two factors 3x minus 2y and 2x plus 5 is equal to 0. Right? So y can have the value as 3 by 2, or y can have x 3 by 2 x, or y can have the value as minus 2 by 5 x. These are the two possible values of y. You have to find out angle between them. Tangent theta will be given by 3 by 2 plus minus minus plus 2 by 5, 1 minus 3 by 2. These are the two equations, right? So the angle between the two lines will be given by product m. This is equal to m1 minus m2 upon 1 plus m1 into m2. Okay. So wait. One plus m1 into m2. So this is the tangent theta. That is the angle between the two lines. Slope is given by this. So that's it. You have this. This will be given by 10 and 15 plus 4 divided by 1 minus 3 by 5. So you have 19 by 10 divided by 2 by 5, which is multiplied by this. So you have 19 upon 4. That is tangent of theta. So theta will be given by tangent inverse of 19 by 4. That's it. This is the answer. But this is in none of the options. But we have root of 361 upon 4 over here. See, 19 square is equal to 361, or 19 is equal to 361 root. So this matches with our answer. Option B. See, I can write this 19 as tangent inverse root 361 upon 4. Okay. Hope you understood this. Option B is the correct answer. Next is question number 48. With the lines joining the origin to the points of intersection of this curve and the line this are right angles, then k square equals to what? Okay. So you have the curve as 2x square minus 2xy plus 3y square plus 2x minus y minus 1 is equal to 0. And the line is given by this. This, or you can say x plus 2y upon k is equal to 1. Right, now let's move to get back to our curve again. This can be written as 2x square minus 2xy plus 3y square plus 2x minus y minus 1 is equal to 0. Right, so I can write it like this. Into 1, and this can be written as minus 1 square, right? So this can be written as 2x square minus 2xy plus 3y square plus 2x minus y into x plus 2y upon k minus x plus 2y upon k square is equal to 0. Multiplying both the sides by k square, you have k square into 2x square minus 2xy plus 3y square plus k into k square. Okay, I'm dividing both, multiplying both the sides by k square. So here you will have 2x plus y into 2x minus y. So 2x minus y into x plus 2y, sorry. Minus this is equal to 0, which gives me, I'm taking x square common. So if you will open this, you will have the x square. The coefficients will be 2k square plus 2k minus 1, and xy will have the coefficient minus 2k square plus 3k minus 4, and y square will have the coefficient as 3k square minus 2k minus 4 is equal to 0. Now these two lines, they are perpendicularly, see the line joining the origin to these points of intersection and the line this, they are at right angles, it's given. So these lines are mutually perpendicular. These lines are perpendicular to each other. If they are perpendicular to each other, therefore the coefficient of x square plus the coefficient of y square will be 0. Right? Which means 2k square plus 2k minus 1 plus 3k square minus 2k minus 4 is equal to 0. This gives me 5k square minus 5 is equal to 0, or k is equal to plus minus 1. Okay, this is it. K is equal to plus minus 1. You have to find out k square, which definitely will be 1. Option D is the correct answer. Hope you understood this. Next is question number 49. Equation of bisectors of the angle between the line represented by this equation is. Okay, so let's write down the equation. This is 3x square minus 5xy plus 4y square is equal to 0. Now comparing it with the general equation, that is ax square plus 2hxy plus by square is equal to 0. You have a as 3, h as 5 by 2 minus 5 by 2, b is equal to 4. Now equation of the bisector of the angle between, you have to find out equation of the bisector of the equation of the bisector of the angle between the line represented by this. So required equation becomes, this is x square minus y square upon a minus b is equal to x into y upon h. This is the formula for that. So this gives you x square minus y square. A was 3, b is 4. That is equal to x into y upon h is equal to minus 5 by 2. Or you have let's solve it further. You have as This will be 5x square minus 2xy minus 5y square is equal to 0. On solving this equation, you will get this equation. Okay. So this matches with option 5x square minus 5y square. This is the one. Option B. Right? I'll take 5 common. X square minus y square is equal to 2xy. That's it. We have option B as the answer. Hope you understood this. Next is question number 50. If the bisector of the pair of these lines is represented by this, then which of the equation is true? Okay, so see, if I'm talking about a general bisector of ax square plus 2hxy is a general equation. This bisectors are given by x square minus y square upon a minus b is equal to x into y upon h. From here, h into x square minus y square will be equal to a minus b into xy, or hx square minus a minus b into x y is minus h y square is equal to 0. Here, in this question, x square will be equal this is the given one. Okay, let's write down this. X square minus 2mxy minus y square is equal to 0. So here you have a is equal to 5. Compare this. In this equation, you have a is equal to 1, b is equal to minus 1, and you have h is equal to minus 2m upon 2, or this is equal to minus m. This is the value for h. And bisector equation is given by this. Bisector equation is given by x square minus 2nxy minus y square minus 2nxy minus y square is equal to 0. This is given to you. And if I fill in these values in this equation, what will be the equation of the bisector? It will be from 1 and 2. Bisector equation will be this will be minus m into x square minus 2xy, right? Yeah. Minus plus m y square is equal to 0. This will be the equation. Now, if I compare both of them, you have minus m is equal to 1, or you can say minus 1 minus m upon 1 is equal to minus 2 upon minus 2n is equal to m upon minus 1. This gives me minus m into n is equal to 1, or 1 plus mn is equal to 0. So this is the required term. So if the bisectors are represent for these pair of line are represented by this, then 1 plus mn is equal to 0. Option A is the answer. Hope you understood this. Next is question number 51. So find the equation of the circle which passes through the origin and cuts off the intercepts at minus 2 and 3 over x and y axis respectively. Fine, you are having here, this is the one. The circle is passing through the origin. So, and the cuts off the intercepts minus 2 and 3 over the, so x-intercept is minus 2 and y-intercept is equal to 3. Therefore, question number 51, find the equation of the circle which passes through the origin and cuts off the intercepts minus 2 and 3 over x and y axis respectively. Now it is cutting the intercepts at minus 2 over the x-axis. This point is given by minus 2 comma 0, and if it is cutting the 3 on the y-axis, this point will be given by 0 comma 3. Okay. And also it is passing through the origin. So that means this is passing through the 3 points. Let's mark it over here. -1, -2, 1, 2, 3. And this is the origin. So this circle is passing through these 3 points for sure. This is somewhat the type of the circle. The center of the circle is going to lie in the second quadrant over here. All right. Now, okay, we are given that x-intercept is -2. So that means 2 root of g squared minus c is equal to 2. Here c is equal to 0 because it is passing through the origin. So see, this is origin actually. Is passing through the origin. This gives me g is equal 2g is equal to 2, or you have g is equal to plus minus of 1 because actually I have square root of this g, right? So this can be written, or g can be equal to plus minus of 1. Similarly, for y, you have 2 of f square minus c is equal to 3, which gives me 2f is equal to plus minus 2f is equal to 3, or f is equal to plus minus 3 by 2. Now, required equation of the circle, I have G as plus minus 1 and F as plus minus 3 by 2. The required equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is a general equation. And in this case, it will be written by x square plus y square plus minus x, because sorry, plus minus 2x, yes, and plus minus 3y, c is equal to 0. So this is it. X square plus, I write down properly once again, x square plus y square plus minus 2x plus minus 3y is equal to 0. Now, the equation, we already discussed about this thing, that the center is lying in the second quadrant. If the center is lying in the second quadrant, of course, we are having the x coordinate of the center. This will be negative, right? So you have x square plus y square plus 2x minus 3y is equal to 0, because you know the center is given by minus g minus f. So this has got to be negative. If this is negative, then this g over here, it will be positive only. Correct? This is the equation of the circle. Let's check with the options. You have option D as the answer. Hope you got that. Next is question number 52. Angle between the pair of tangents drawn from 1, 1 to this circle is. Okay, so you are having the circle. This is the equation of the circle. So this is the point 1, 1. The angle between the pair of tangents. Let's draw the two tangents first from here. So if this is the point, all right. So this is the, according to here, the equation of the circle is x square plus y square plus 4x plus 4y minus 1 is equal to 0. This center is given by, you know, that is minus g minus f, that is minus half the coefficient of x, which is minus 2, minus half the coefficient of y, which is minus 2 again. So the center over here is O minus 2 minus 2. And you know, there is a perpendicular, the radius falls perpendicular in the tangent of the circle, right? And let's say this is point Q, let's say this is P and this is O. So OPQ is a right angle triangle now. All right, one more thing, radius is given by root of g square plus f square minus c. So this is equal to minus 2 square 4 minus 2 square 4, c is equal to this. So this is equal to 3. This is the radius of the circle. That is OP. All right. Yeah. So now this, you have to find out angle between the pair of tangents. So this, if I take this as theta, then sine of theta is, you know, perpendicular upon, sine theta is equal to perpendicular upon hypotenuse. So in this case, for theta, the perpendicular is OP and hypotenuse is OQ. Let's find out OQ also. OQ will be given by distance formula. This is minus 2 minus 1, which is minus 3 square, plus minus 2 minus 1, this is minus 3 square. So this is equal to 3 root 2 OQ, right? That is OP upon OQ. OP is equal to this and this. So you have 1 by root 2 or this is equal to sine of 45 degrees. So theta over here is equal to 45 degrees. What do you have to find out in the question? Angle between. See, if this is theta, then this is also theta. Right? These two triangles, they are congruent to each other. If this is theta, this is also theta. So the angle between them is equal to 2 theta. Angle between tangents is equal to 90 degrees. That is pi by 2. Option A is the answer. Hope you got that. Next is question number 53. If the circles this intersect the line this in two distinct points, then the number of integral values of m is equal to. You are given the circle as x square plus y square minus 4x minus 8y minus 5 is equal to 0. The center is given by minus g minus f, that is 2, 4, and radius will be equal to root of g square x square minus c, which is equal to root of 2 square 4, 4 square 16 minus minus plus. So this is equal to 5, right? Now the line is given by 3x minus 4y minus m is equal to 0. So that means it's something like this. The point, the circle is intersecting the line at two distinct points, right? Therefore, the distance of the line from center, distance of line from center is of course less than the radius. Question number 53. If the circle this intersects this line in two distinct points, then the number of integral values of m is equal to. So you're given the circle as x square plus y square minus 4x minus 8y minus 5 is equal to 0. Now the center is given by minus half the coefficient of x minus half the coefficient of y, which is equal to 2 and 4. Similarly, the radius is given by root of g square plus f square minus c. This is equal to root of 2 square, that is 4, 6, 4 square is this, minus minus plus, so this is root of 25, or the radius is equal to 5. Now the given line is given by 3x minus 4y minus m is equal to 0. According to the question, distance of line from center is less than the radius of the circle. That means the distance, this is given by this line from the center, distance is given by 3 into 2 minus 4 into 4 minus of m whole divided by root of 3 square plus minus 4 square is less than radius. So this is 6 minus 16 minus m upon root of 9 plus this is 25 is less than this. This makes it minus 10 minus m mod is less than 5 into c. This is 5 and cross multiplication, this will be 25, right? So that means this 10m minus 10 minus m lies between minus 25 to 25 because there is a mod function over here, right? So that means this expression lies between minus 25 to 25. So this will be minus 15 is less than m is less than 15, this is 35, right? Or you can say m is greater than 15 and it's greater than minus 35. Okay. So how many now though, how many possible values are there between the 15 and 35? You have 49 possible values. So between them, you have 49 possible values of m. That is option D. Hope you got that. Next is question number 54. Let's see with the circle with center 0, 0 and the radius 3 units. Let's say this is the center and the radius is 3. So 3, 3, 3, 3. The equation of the locus of the midpoint of the chords of the circle C that subtend an angle of 2 pi by 3 at its center is. Okay, so very first thing, let's say A be the point over here. Okay, let A be the point which is given by 3 cos theta and 3 sin theta. So then B will be given by 3. These are the 2 points of the chord. So this will be given by 3 into cos theta plus 2 pi by 3, 3 sin theta plus 2 pi by 3. Now let the required point be H and K. Let required point be H comma K. So therefore you have 2H is equal to 3 cos theta plus 3 cos theta plus 2 pi by 3 and 2K. Let's solve it first, then we'll talk about the rest. 2K. This is equal to 3. I'll take 3 cos theta plus cos minus 1 by 2 minus sine root 3 by 2. This is equal to 3 by 2 cos theta minus 3 sin theta. Similarly, you have 2K is equal to 3 sin theta plus 3 sin theta plus 2 pi by 3. So this is equal to 3 will be taken common, sin theta plus sin minus 1 by 3 plus cos this. So that is equal to 3 by 2 sin theta plus root 3 of cos theta. Right. Now, cos theta minus 3 sin theta is equal to 4h by 3. This gives you root 3 cos theta plus sin theta is equal to 4 by 3. So you have these two values. Okay. So question number 54. Let C be the circle with the center as origin and radius as 3 units. So this is the circle. If the center is at origin, this, and the radius is 3. So these 4 sides are equal to 3. The equation of locus of the midpoint of the chords of the circle that subtend an angle of 2 pi by 3 at its center. So, sorry. Okay, I'll make it again. So this was the circle. This was the origin. Let's say this is point A and let's say this is point B, and the chord AB is making an angle of 2 pi by 3 at its center. Let's say the coordinates of E are 3 cos theta, 3 sin theta. Then what will be the coordinates of P? It will be 3 cos theta plus 2 pi by 3 and 3 sin theta plus 2 pi by 3. Now let HK be the required point. So if HK is the required point, then 2H is given by 3H, 3 cos theta plus 3 cos theta 2 pi by 3. And this is according to midpoint formula, because H is the midpoint on the line AB. So 2H is equal to this, which gives you this. I'll take 3 common, cos theta plus cos, see, I'll consider this as A and B. So this cos A plus B is equal to cos A cos B minus sin A sin B. So I'll write it as cos theta into cos 2 pi by 3 minus sin theta into sin 2 pi by 3. Okay. So that is given by 3 into cos theta into cos 2 pi by 3 is equal to minus 1 by 2, and sin 2 pi by 3 is equal to root 3 by 2. That gives you cos theta minus 1 by 2 cos theta will be equal to cos 1 by 2 cos theta. And this is minus root 3 by 2 sin theta. I'll take 2 outside. This will be 3 by 2 cos theta minus root 3 sin theta. Now, similarly, this was for h. Similarly, for the k is the y coordinate of the midpoint of AB. So, k will be given by, I'll say 2k is equal to 3 sin theta plus 3 sin theta plus 2 pi by 3, which is equal to 3 will be taken outside, sin theta. Now, this is sin A plus B thing, sin A cos B plus cos A sin B. So, this will be equal to sin theta into sin 2 pi by, cos into cos 2 pi by 3 plus cos theta into sin 2 pi by 3. Okay, so this is 3 sin theta plus sin theta. And see, cos 2 pi by 3 is equal to minus 1 by 2 plus cos theta. This is equal to root 3 by 2. Again, the same thing, you have 3 sin theta by 2 plus root 3 by 2 into cos theta. I'll take 2 outside. So this is equal to 3 by 2 sin theta plus root 3 of cos theta. Okay. So that was equal to your 2k. This will give you 4k upon 3 is equal to sin theta plus root 3 cos theta. And similarly, from this equation, that was equal to 2h. From this equation, 4h upon 3 is equal to 4h upon 3 is equal to cos theta minus root 3 sin theta. Now, multiplying both sides by root of 3, this will give you 4h into root 3 upon 3 is equal to root 3 cos theta minus 3 sin theta. That is equal to 4h upon 3 is equal to root 3 cos theta minus 3 sin theta, right? So, let's subtract 1 and 2. Subtracting 1 and 2, you have here 4k upon 3 minus 4h upon, this was supposed to be root 3. Root 3 is equal to sin theta plus root 3 cos theta minus root 3 cos theta plus 3 sin theta. This will cancel and you have 4 sin theta is equal to 4 by, I'll take 3 over here as common because I'll be multiplying the numerator and the denominator by root 3. Okay, so this is equal to, 4 by 3 I have taken common and this is k minus root 3h, or sin theta will be equal to k minus root 3h upon 3, right? So if this is the value for sin theta according to this, now what will be the value of cos theta? See, cos theta is given by root of 1 minus sin square theta. So this is equal to 1 minus k minus root 3h upon 3 square, which is equal to 3 square is 9. So 9 minus k minus root 3h square upon 9 itself. So that is equal to 1 by 3 root of 9 minus k square minus k. This is supposed to be minus. Okay. Minus 3h square plus 2 root 3 kh. But I will do one thing. I instead of going like this is becoming a bit typical. So I will put this sine theta value in this equation. Okay. So let's see what comes out to be 4k upon 3 from this equation 1. From equation 1, you have 4k upon 3 is equal to root 3 cos theta plus sine theta, or root 3 cos theta is equal to 4k upon 3 minus sine theta was equal to k minus root 3 h upon 3. So this makes it 4k minus k plus root 3h upon 3, or 3k plus root 3h upon 3. This is the value for root 3 cos theta. Let's divide it. So this will come at this place. Okay. So cos theta is equal to 3k plus root 3h upon 3 root 3. This is the value for cos theta, and sin theta was calculated as k minus root 3h upon 3. Correct. What we had to find out in the question is this. Let's check once again. Locus, equation of the locus of the midpoints. Fine. So over here, you know one thing, sine square theta plus cos square theta is equal to 1. So I'll square them and add them. So after squaring this sine square theta, you have k minus root 3h upon 3 square plus 3k plus root 3h. See, I'll do one thing. I'll take root 3 common and I will divide. So this will be root 3 plus h upon 3 square is equal to 1. Correct? This will give you k square plus 3h square minus 2 root 3 h into k plus 3k square plus h square plus 2 root 3 h into k is equal to 9. This is gonna give me 4k square plus 4h square. These two will cancel, is equal to 9, or 4h square plus k square is equal to 9. H square plus k square is equal to 9 by 4. This replacing h with x and k with y gives you x square plus 9 square is equal to 9 by 4. So this is the answer to the question. Option C is the correct answer. Hope you understood this. Let's move to the next question, number 55. The length of the common chord of these two circles is dash units. Fine. So first circle is given by x square plus y square plus 3x plus 5 plus 4 plus 5y plus 4 is equal to 0. And the second is given by x square plus 5 square plus 5x plus 3y plus 4 is equal to 0. So if I subtract these two equations to find out the common point, right, this will give me x square, y square, they will cancel, and this will be equal to minus 2x plus 2y is equal to 0, which gives me x is equal to y. So if x is equal to y, this equation becomes 2x square plus 8x plus 4 is equal to 0, and this equation will be 2x square plus 8x plus 4 is equal to 0. So same thing, see, the same equations are there. So you can write as x square plus 4x plus 2 is equal to 0, which is the perfect square for x plus 2. No, sorry, this is not the perfect square for this. This can be written as x plus 2 whole square minus 2 is equal to 0, or x plus 2 whole square is equal to 2, right? That means x plus 2 can have the value as plus minus 2, which means x plus 2 can be equal to positive 2, or x plus 2 can be equal to negative of 2. Okay. So, sorry, root 2. Right? Therefore, the length is given by root of x1 minus x2 square plus y1 minus y2 square. That is equal to root of x minus x2 square. Since x and y were equal, so x1 minus x2 square, this will be equal to root 2 into x1 minus x2, right? So what were the two values for x? See, from here, the one x was equal to root 2 minus 2. And from here, the x was equal to minus root 2 minus 2. So let's fill in these two values for the x. You will have this equation as root 2. X1 was root 2 minus 2 minus minus plus root 2 plus root 2. So these two will cancel. And you have 2 into 2 root 2, which is equal to, root 2 into 2 root 2, which is equal to 2 into 2, that is equal to 4. So the answer to the question is 4. Option D is the correct answer. Hope you understood this. Next is question number 56. You have to find the equation of the circle which is passing through 1, 2 and the point of intersection of these two circles. All right. So you have to find the equation of the circle which is passing through this point and point of intersection of these two circles, right? So this equation will be, since it is passing through the points of intersection of these two circles, so the equation of the circle will be given by x square plus y square minus 8x minus 6y plus 21 plus some lambda x square plus y square minus 2x minus 15 is equal to 0. Right now, since this is passing through the point 1, 2, this can be written as 1 plus 4 minus 8 minus 12 plus 21 plus lambda into 1 plus 4 minus 2 minus 15 is equal to 0. This gives you 6 plus lambda into minus 12 is equal to 0. That gives you lambda is equal to 1 by 2. Okay, we got the value of lambda. So now this equation becomes x square plus y square minus 8x minus 6y plus 21 plus 1 by 2 into x square plus y square minus 2x minus 15 is equal to 0. Let's multiply both the sides by 2. You have 2x square, 2y square minus 16x minus 12y plus 42 plus x square plus y square minus 2x minus 15 is equal to 0. That makes the equation as 3x square 3y square minus 18x minus this will be 12y plus 27 is equal to 0. So that's it. Let's take 3 common. X square plus y square minus 18x 12y 27 is equal to 0. This is the answer to the question. Option C is the correct answer. See, you could have taken 3 common from all of them, but this was not present in the option. So I rather took only 3 common from x square and y square. Hope you understood this. Next is question of 57. It says the coordinates of the locus of the parabola described by parametrically this equation where t is a parameter r. All right. So you are given x is equal to 5t square plus 2 and you are given y is equal to 10t plus 4. Here you get the value of t as y minus 4 upon 10. From this equation, you can say x minus 2. I'll fill in the value of t. X minus 2 is equal to 5 into y minus 4 upon 10 whole square. That gives you y minus 4 whole square is equal to, this is equal to, see, this is 10 square. So this will be 1 upon 20 only. See, this will be 5 upon 100. That will be 1 upon 20. This 10. Okay. Fine. So y minus 4 whole square is equal to 20 into x minus 2. Which makes, according to this, which makes, see over here, you have x minus 2. When x minus 2 is equal to 5. Question number 57. The coordinates of the focus of the parabola described parametrically by x is equal to 5t square plus 2 and y is equal to 10t plus 4, where t is a parameter r. So we are given the two equations as x is equal to 5t square plus 2 and y is equal to 10t plus 4. Or you can have here x minus 2 upon 5 is equal to t square, right? And from here you have y minus 4 upon 10 is equal to t. Let's fill in this value of t in this equation. You will have x minus 2 upon 5 is equal to y minus 4 upon 10 square. That gives you that gives you y minus 4 whole square is equal to 5 upon 100. Sorry, that's equal to 100 upon 5 into x minus 2. This is equal to y minus 4 square is equal to 20 into x minus 2. Now this is of the form y square is equal to 20 into x. That's equal to 20 into x, where y is equal to y minus 4 and x is equal to x minus 2. Correct? Okay. Now the coordinates of the focus in this are 5, 0 because this is equal to 4ax and a in this case is 5. So here the focus is 5, 0, which means x minus 2 is equal to 5 and y minus 4 is equal to 0, which gives me y as 4 and x as 7. Therefore, the required coordinates of the focus are coordinates of focus are 7, 4. So this is 7, 4, option A as the correct answer. Hope you got that. Let's move to the next question. Question number 58. If tangent of theta 1, tangent theta 2 is equal to minus a square upon b square. This is actually not comma. This is a multiplication. So then the chord joining 2 points, theta 1 and theta 2, 1 on the ellipse, this will subtend right angle at what? Focus, center, end of major or minor axis. So first of all, let's say the 2 points be A, be given by A cos theta 1, B sin theta 1, and the B second point be given by A cos theta 2, B sin theta 2. And origin O is given by 0, 0. Now, the slope of 0 to A, this is given by B sin theta 1 upon A sin theta 1. Actually, minus 0, 0, right? So, this will ultimately give you B sin theta 1 upon A sin theta 1. Sorry, cos theta 1. Oh, wait. It was supposed to be B sin theta 1 upon A cos theta 1. Right? Minus 0 for the origin. Minus 0. So, this is equal to B sin theta 1 upon A cos theta 1. Similarly, the slope of OB will be given by, this is given by B upon A, tangent of theta 1. Similarly, OB is given by B sin theta 2 minus 0 upon B cos theta 2, A cos theta 2 minus 0. So, that is equal to B sin theta 2 upon A cos theta 2, which is equal to B upon A tangent of theta 2. Now, if they subtend right angles, that means MOA into the product of these two slopes is equal to minus 1, should be equal to minus 1, right? Let's check whether it is minus 1 or not. So, this is equal to BA into tangent theta 1 multiply BA into tangent theta 2. This is going to give me B square upon A square tangent theta 1 tangent theta 2. This tangent theta 1 into tangent theta 2 was equal to minus a square upon b square. So this gives me b square upon a square into minus a square upon b square, which is equal to minus 1. So these two slopes, they are perpendicular to each other because the product of them came out to be minus 1. That means they subtend right angle at the center. That is the center. They subtend right angle at the center. Okay. Option B is the correct answer. Hope you understood this. Let's move to the next question. Question number 58. If tangent of theta 1, there's a multiplication sign into theta, tangent of theta 2 is equal to minus a square upon b square. Then the chord joining 2 points theta 1 and theta 2 on the ellipse, this will subtend a right angle at focus, center, end of major or end of minor axis. Fine. So let's say the 2 points be A as A cos theta 1 and B sine theta 1. And let's say the another point be A cos theta 2, B sine theta 2. And let's say the origin, you know the coordinates, that is 0 and 0. So what do you think? There is slope that is M of OA will be given by, it will be given by B sine theta 1 minus 0 upon B cos theta, A cos theta 1 minus 0, which is equal to B sine theta 1 upon cos theta 1 upon A, or that is equal to B upon A tangent of theta 1. Similarly, the slope MOB is equal to B sine theta 2 minus 0 upon A cos theta 2 minus 0, which will give you B upon A tangent of theta 2. Right. So let's find the product of the two slopes. MOA into MOB. That will give you B upon A into tangent theta 1 multiply B upon A tangent theta 2, which will give you B upon A tangent theta 1 into tangent theta 2. And this was equal to minus A square upon B square given over here. So, sorry, here is square. Okay, these two will be multiplied. So B square upon A square multiply minus A square upon B square is equal to minus 1. Since the product of the slopes is equal to minus 1, since product of these two slopes is equal to minus 1, therefore the chord subtends right angle at origin, which in this case, the origin is nothing but the center. So that means we have option B as the answer. Hope you understood this. Next is question number 59. It says if one focus of the hyperbola is 3, 0 and equation of the directrix is given by this, eccentricity is given by this, then what are the coordinates of its vertex? Okay. Now distance from focus to directrix is given by A into E minus 1 upon E, that is equal to E was equal to 5 upon 4 minus 4 upon 5, which will be equal to, okay, this is equal to 4. I'll take the LCM, 20. Now this is equal to distance of this directrix from the focus. That will be given by the mode of 4 multiply 3. This 4 multiply 3. Minus 3 multiply 0, which is 0. Minus 3 whole divided by root of 4 square plus 3 square. So here you have, this will be A into 9 upon 20 is equal to 12 minus 3, that is 9 upon root of 25, that is equal to 5. This gives you A is equal to 4, right? Therefore, okay, now, if I'm talking about this directrix 4x minus 3, wait. Directrix was given to you as 4x minus 3y minus 3 is equal to 0. This gives you 3y is equal to 4x minus 3 or y is equal to 4 by 3. x minus 1. So what is the slope of this axis? Number 59, if one of the focus of the hyperbola is 3, comma 0, and equation of the directrix is given by this. Eccentricity is equal to 5 by 4. Then the coordinates of the vertex are what? All right. So first thing, if I talk about the distance of from focus to directrix is given by the formula A into E minus 1 upon E. So now this is, I don't know what the value of E, but E is 5 by 4 minus 4 by 5. Now this distance of this line from this point is given by 4 into 3 minus 3 into 0 minus 3, the mod of it, root of 4 square plus minus 3 square, which is equal to A into 25 minus 16 upon 20. That is equal to 12 minus 3, 9 upon root of 25. Right, root of 25 is equal to 5. So this will cancel at 4. Okay, wait. I can write it like A into 9 upon 20 is equal to 9 upon 25. So, sorry, 5. This is 4 and you will get the value of A as 4. All right. Now, the directrix equation is 4x minus 3y minus 3. Directrix is 4x minus 3y minus 3 is equal to 0, which gives you 3y is equal to 4x minus 3 or y is equal to 4 by 3x minus 3. So this is the slope 4 by 3 for this. So slope of x's will be given by minus 3 by 4, right? Now distance of the vertex, distance of vertex to focus will is given by A into E minus 1. So A we already calculated, that was 4. E was equal to 5 by 4, yes. So this is equal to 4 into 1 by 4, that is equal to 1. So distance of the vertex to the focus is equal to 1. Now, the parametric form of vertex is parametric equation or form of vertex is 3 plus r into minus 4 by 5. So this was the value of A was equal to 4. Let's calculate B also. Okay, we have to calculate B. You know, centricity square is equal to 1 plus B square upon A square. The centricity was 5 by 4. So this is 25 by 4 is equal to 1 plus B square upon 16. Here is 16. And 25 upon 16 is equal to 16 plus B square upon 16, which gives you B square is equal to 9, or B is equal to plus minus 3. Okay, so here you have same thing. I'll write down parametric form over here. So parametric form is given by 3 plus minus r into minus 4 by 5, 0 plus minus r into, that is B, 3 by 5. Okay, right. So what is r over here? R is actually distance, this distance of the vertex to the focus. This is equal to r. So this makes the vertex as 3 minus, this was minus, so 3 minus, r was 1, so minus 4 by 5, comma, that is 3 by 5, because r is equal to 1. So this makes it 11 upon 5, comma, 3 upon 5. That is option B. So you have this answer to the question. Hope you got that. Next is question number 60. If the vertices of the triangle are 1, 2, 3, 3, 2, 1, 3, 1, 2, and if H, G, S, I respectively denote its orthocenter, centroid, circumcenter, incenter, then H plus G plus I plus H plus G plus S plus I is equal to. It's the same. You're given these vertices. This is, let's say, A1, 2, 3. And this is 2, 3, 1. This is 3, 1, 2. If you will calculate AB square, this will be given by, okay, this is B and C. So AB square will be given by 2 minus 1, that is 1 square, plus 3 minus 2, 1 square, plus 1 minus 3, that is 2 square, which is equal to 1 plus 1 plus 4, that is equal to 6. Now let's go for BC square. BC square is again minus 1 square plus 2 square plus 1 square, which is 6. And AC square is 2 square plus minus 1 square plus minus 1 square, which is 6. So you have all the three equal. AB square is equal to BC square is equal to AC square. That means the triangle is an equilateral triangle. Okay, so if this is an equilateral triangle, let's calculate the centroid, orthocenter, circumcenter, everything. So here, the centroid is given by, you know the formula, it is x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3, z1 plus z2 plus z3 upon 3. So let's add all the points. You have 1 plus 2 plus 3 upon 3, 2 plus 3 plus 1 upon 3, 3 plus 1 plus 2 upon 3, which makes it 6 upon 3, which is 2, 2, 2. This is what? The centroid of the triangle. Right. Now, in an equilateral triangle, the centroid, orthocenter, circumcenter, incenter, they all are same. So, H is equal to G is equal to S is equal to I. This centroid was denoted by G. So, that was your G. So they are all equal, and that is represented by 2, 2, 2. You have to find out H plus G plus S plus I, which makes it like adding all of them, you will have 8, 8, and 8. So this is the answer to the question. Option D is the correct answer. Hope you understood this. Let's move to the next question. Number 61, A, B, C, D. These are the 4 points, and line AB vector is parallel to CD vector. Then what is the value of K? You have to find out, right? Now, if AB is parallel to CD vector, then you can say that AB vector is equal to some lambda times CD vector, right? And what is AB vector? If I'm talking about the direction ratios, so AB direction ratios will be given by 4 minus 2, that is 2. See over here, 4 minus 2, then 5 minus 3, which is 2 again, then 7 minus 4, which is equal to 3. This is equal to lambda times direction ratios of CD, which is 4 minus 2, that is equal to 2. Minus 4 minus minus plus 6, that is 2 again, K minus 3. Right? So that means from here, K minus 3 is equal to 3. Which gives you K is equal to 6, and option D is the correct answer. Hope you got that. Let's move to the next question. Question number 62, the direction cosines of the two lines are given by this and this. Then identify the direction ratios of a line which is bisecting one of the angle between them. Okay. So let's say P be defined by that angle bisector. Okay. So if this is the angle bisector, then the direction ratios of this P will be given by 1 by 2, since it's bisecting the angle, 1 by 2, 2 by 3, plus minus 5 by 13, 2 by 3, plus minus 12 by 13, and 1 by 3, plus minus 0. Okay, 2 by 3, plus minus 5 by 13, 2 by 3, plus minus 12 by 13, and 1 by 3, plus minus 0. Half of that. So that is equal to, since only the positive values are there, so I'll be taking the positive values. So let's take, this is 39. That's gonna give me 26 plus 15. And this has got to be 39, 26 plus 26, and this is 3, 1 by 3 as such, right? So since these are having the denominator 13, I'll make this one also like this. Fine. So you have this as 1 by 2. This is 41 by 39. This is 62 by 39. And that is equal to 13 upon 39, right? I hope you got this. Now, parallel to this vector, any vector parallel to this vector will have the direction ratios as 41, 62, and 30, right? So this is the correct answer to the question. Option C is the right answer. Hope you understood this. Let's move to the next question, number 63. Limit n into 2n plus 1 whole square, limit n approaching 0, n into 2n plus 1 whole square, n in plus divided by n plus 2, multiply n square plus 3n minus 1 is equal to. So here you have limit n approaching infinity, n into 2n plus 1 whole square upon n plus 2 upon n square plus 3n minus 1. Now this is equal to coefficient of n cube in numerator divided by coefficient of n cube in denominator. This is the formula for it. I'll also let you know how did I get onto this formula. Okay, for the time being, just note on this formula because in the entrance exams, such shortcuts are very helpful. So what will be, see, according to this, when you will open this up, this will be equal to n into 4n square plus 1 plus this will be 4n. Okay, and divided by, I'm just worried about the coefficient of n cube. So this is, I'll just let it be like this only. N plus 2, n square plus 3, n minus 1. So what do you think? This is the coefficient of n cube in the numerator, it is 4, and the coefficient of n cube in the denominator is 1. So that means you have 4 as the answer. Easy as that. So now let's discuss, okay, we have option B as the answer. Let's discuss why is this so, coefficient of n cube in the numerator on the denominator. Or you can understand the whole sum as like, it was limit n approaching 0. It is n into 2n plus 1 square divided by n plus 2 into n square plus 3n minus 1. So that is equal to, I'll open up the numerator and the denominator, leaving limit n approaching infinity, n into 4n square plus 1 plus 4n whole divided by n cube plus 3n square minus n plus 2n square plus 6n minus 2. That is equal to limit n approaching infinity. You will have 4n cube plus 4n square plus n, and the denominator will have n cube plus 5n square plus 5n minus 2. Now dividing numerator and denominator by n cube. You will have limit n approaching infinity 4 plus 4 upon n plus 1 upon n square whole divided by 1 plus 5 upon n plus 5 upon n square minus 2 upon n cube. Now when n approaches infinity, you will be left with 4 upon 1, that is equal to 4. So just remember this formula so as to avoid such a long calculation. You can simply say the coefficient of the highest power of the variable in the numerator divided by the coefficient of highest power of the this variable in the denominator as well. So we have 4, that is option B as the correct answer. Hope you understood this. Next is question number 64. If the function fx defined below is continuous in the interval 0, 8, then which of the following is true? Fine. So it is continuous in this interval, and the interval is like from 0 to 2, the function will be taken as this. From 2 to 4, the function will be taken as this, and 4 to 8, the function will be considered this. So now, if I take limit x approaching 2 minus fx is equal to f of 2, right? I'll take this. I'll take this one, this function. Now, we are given that fx is continuous from 0 to 8. So that means it's continuous at 2 and 4 as well, right? So if it's continuous at 2 and 4, you can write it as f of 2 is, that means x squared plus ax plus b is equal to 3x plus 2 at x is equal to 2. So that makes 4 plus 2a plus b is equal to 3 into 2 plus 2, or 2a plus b is equal to 6 plus 2, that is 8, minus 4. 2a plus b is equal to 4. Okay. Now, the second one, limit x approaching 4 plus fx is equal to f of 4. Similarly, it's given that the function is continuous at x is equal to 4. So that means 3x plus 2 is equal to 2ax plus 5b at x is equal to 4. Since function is continuous at x is equal to 4, it's given that the function is continuous in this interval. So that means this function is continuous at x is equal to 4 as well. Therefore, 3x plus 2 is equal to 2ax plus 5b. At x is equal to 4, this makes 3 into 4 plus 2 is equal to 2a4 plus 5b. Or you have 14 is equal to 8a plus 5b. So you have these two equations. This is, let's say, number 1 and, number 2 and number 1. Okay. So let's solve them. 2a plus b is equal to 4. So let's multiply this equation with 4 and solve here. Okay, I have 2a plus b is equal to 4, which gives me 8a plus 4b is equal to 16. So 16 is equal to 8a plus 4b minus minus minus, they will cancel. And here was 5. You have b as minus 2. You got the value of b as minus 2. So 2a plus b was 4. 2a minus 2 is equal to 4, or a is equal to 3. So you got the value of a and b. This is what we needed in the question, right? A is equal to 3 and b came out to be minus 2. That means we have option A as the answer. Hope you got that. Next is 65th question. Fx defined below is continuous at x is equal to 4. Then which of the following, for these functions, fx is equal to this when x is less than 4, it's this when x is equal to 4, and this when x is greater than 4. It's given that it is continuous at x is equal to 4, which simply means, what do you mean by it's continuous? See, when I say it's continuous, that limit x approaching 4 minus fx is equal to f of 4 is equal to limit x approaching 4 plus fx. For x approaching 4 minus, you are given the function as x minus 4 upon mod of x minus 4 plus a is equal to f of 4, that is a plus b, is equal to this x minus 4 upon mod x minus 4 plus b. Fine. So I'll pick up the first pair from here. You have, I'll put x is equal to 4. So this gives me 4 minus 4, that is equal to 0. No, not sorry, 0, but because this is x approaching 4 minus. So this term is slightly less than 4, which will give this term to be negative by some figure, right? And by the same figure, this will be a positive value because there is a mod function around it, right? So this will be negative of the same value plus the positive of the divided by the positive of the same value is equal, plus a is equal to a plus b, right? Question number 65, if fx defined below is continuous at x is equal to 4, then fx is given by this function when x is less than 4, given by this when x is equal to 4, given by this when x is slightly or more than 4. Okay, so these are the three values for x and the corresponding functions. Now you are given that this is a continuous function at x is equal to 4, which simply means that limit x approaching 4 minus fx is equal to f of 4 is equal to limit x approaching 4 plus fx. All right. So what will be this when you're having 4 minus this term, this particular term, because the numerator and the denominator, they are same by the figure, but only the signs are different, right? See over here. These two figures are same, only the signs are different. For 4 minus, the numerator is going to be negative and the denominator will be positive by the same amount. That means it will be minus 1 plus a, and f of 4 is given by a plus b is equal to, now this will be positive in this case, and the numerator and denominator both are going to be positive in this case. That is surely going to give you positive 1 plus p, right? So now you have two values as minus 1 plus a is equal to a plus b, which gives you b is equal to minus 1. Also, a plus b is equal to 1 plus b. That gives you a is equal to 1. You got the value of a and b. That is what you needed. That is option D. Hope you understood this. Next is question number 66. If fx is equal to 2x squared plus 3x minus 5, then you have to find the value of f dash 0 plus 3f dash minus 1. Okay, to answer the question, I have to find out the first derivative for the function fx is equal to 2x squared plus 3x minus 5. So f dash x will be given by 4x plus 3. F dash 0 will be equal to 3. And similarly, f dash minus 1 will be equal to 4 into minus 1 plus 3, which is equal to minus 1. And when it's multiplied by 3, it will be minus 3, right? So you have to find the sum of 2 according to the question. F dash 0 plus 3, f dash minus 1 is 3 minus 3, which is 0. Option B is the correct answer. Hope you understood this. Next is 67th question. You are given y is equal to 1 plus x into 1 plus 2 x, 2 upon x, 1 plus 3 upon x, so on till 1 plus n upon x, where x is not equal to 0. When x is equal to minus 1, then what is dy by dx is equal to? All right, students. See, you are given this y function. Let's write it down once. It's equal to 1 plus 1 upon x, 2 upon x, 3, and so on, n upon x, right? So let's find the derivative of it. dy upon dx. This is given by, see, once the derivative is 0, it's a constant. 1 upon x will have the derivative as minus 1 upon x square into 1 plus this, so on. It will be very lengthy if I keep on writing every term. Plus 1 plus x. Now, the derivative of the second term, this will be minus 2 upon x square, so on, 1 plus n upon x. And so on, like next time it will be derivative of the third term and all that, right? Now, when I put x is equal to minus 1, what this will be? dy by dx will turn out to be, this will be minus 1. The second term will be 1 minus 2, that is equal to minus 1 again. Then it will be minus 3, because for 1 plus 3 upon x, it will be 1 minus 3, which will give me minus 2. So on till minus n plus 1 plus 0. This will be equal to minus 1 raised to power n into n minus 1 factorial. That's it. You have option C as the correct answer. Hope you understood this. Next, question number 68. Derivative of sine square into sine square of cot inverse root of 1 plus x upon 1 minus x is equal to. Okay, so I'll assume let x is equal to cos theta. 2 theta, let's say. Let's say x is equal to cos theta, and d theta upon dx will be given by, I'll solve it first. So dx will be given by sine 2 theta upon 2 into d theta, or d theta upon dx will be given by question number 68. You have to find out d by dx of sine squared cot inverse root of 1 plus x upon 1 minus x. To answer, let's put x is equal to cos 2 theta, differentiating both sides. You have dx is equal to minus 2 sine 2 theta into d theta. Or you can say d theta upon dx is equal to minus 1 by 2 sine 2 theta. Right, now let's get back to our problem. We had d by dx of sine square cot inverse root of 1 plus cos 2 theta 1 minus cos 2 theta, which is equal to d by dx of sine square cot inverse. This is equal to 2 cos square theta under the root upon 2 sine square theta. 2 and 2 will cancel. You have a d by dx of sine square. Now this is cot inverse of cot theta, which is equal to d by dx of sine square theta. And what is that? That is given by 2 sine theta cos theta into d theta. Or this is equal to sine 2 theta. Sorry, this was d theta upon dx. So into d theta upon dx, we already solved that. That was equal to minus 1 by 2 into sine 2 theta. So that is minus 1 by 2 sine 2 theta, which is equal to minus 1 by 2. So you have option C as your answer. Hope you understood this. Let's move to the next question number 69. If y is equal to tan inverse ax minus b upon bx plus a, then y dash is equal to. Students, before answering this question, as a quick reminder to visit our website www.examsnet.com to explore this and many more entrance exam question papers with their PDFs. You can also download our app. The link is available in the description box. So here we go. Question number 69, y is given by this. So let's write down y is equal to tangent inverse ax minus b, bx plus a. You have to find out y dash. This will be the tangent inverse x derivative is given by 1 upon 1 plus x square. So using that same thing, you will have this as 1 upon 1 plus ax minus b, bx plus a whole square. Now into the derivative of this. So this derivative is given by the denominator square, bx plus a whole square in the numerator will be denominator, multiply the derivative of the numerator, which is a, minus numerator into the derivative of denominator. Hope you got that. So now y dash is equal to 1 upon so this is bx plus a whole square. Here will be bx plus a square, ax minus b square into this will be abx plus a square minus abx plus b square. So these two will cancel and the denominator will have bx plus a whole square. These two will also cancel. And ultimately you will have over here, this will be a square upon b square divided by, this will be, let's open this up. This is b square x square plus a square plus 2abx plus a square x square plus b square minus 2abx. Of course, they will cancel. You have a square upon b square upon a square plus b square plus, I'll take the x square common, a square plus b square, which is a square plus b square x square plus 1 upon this. So this will cancel, and you have this as 1 upon x square plus 1. This is the answer. Let's check. You have option B as the correct answer. Hope we got that. Next is 70th question. Y is equal to 4x minus c is a tangent to this curve at 3, 6. Then the values of A and B are. Okay. So you are given the curve y. This is a tangent to this curve. Y square is equal to ax raised to power 4 plus b. So let's find out the derivative. You will have 2y dy by dx is equal to 4a x cube. And this derivative at this point, okay, I'll say dy by dx is given by 2ax cube upon y. So dy by dx at 3, 6 is given by 2 into a into 3 square is 3 cube is 27 upon 6. That's going to give you 9a, right? So see one thing, this is the tangent to this curve. So y is equal to 4x minus c. Tangent is given by y is equal to 4x minus 6. So here the slope is equal to 4, and this is the slope. See, at the point 3, 6, the slope is given by 9a, and also the slope of the tangent at this point is 4. Therefore, 9a is equal to 4, or a is equal to 4 by 9, right? So let's get back to our equation over here. You have to find out the values of a and b. So for this curve, y square is equal to ax raised to power 4 plus b. You have to find the value of a and b. A we already got, and this was at the point 3, 6. This is satisfying this curve. So 6 square is equal to 4 by 9 into a. A was 4 by 9 into, 3 raised to power 4 plus b. So 36 is equal to 4 into 9 upon 9 plus b, which is gonna give you 36 is equal to 36 plus b, which means b is equal to 0. That's it. You got your answer. B is equal to 0, and a was equal to 4 by 9. Okay. So according to this, you have option D as the answer. Hope you understood this. Next is 71st question. Find the positive value of A for which the equality 2 alpha plus beta is equal to A holds, where alpha and beta are the points of maximum and minimum respectively of the function given by this. Okay. So here you are given that 2 alpha plus beta is equal to 8. It's given over here. And fx is given by 2x cube, 9 ax square, 12 a square x. So f dash x will be given by 6x square minus 18 ax plus 12a square. Now for critical points, you know, the derivative, first derivative need to be 0. That means f dash x, which is 6x square minus 18x square plus 12a square should be equal to 0, or x square minus 3ax plus 2a square should be equal to 0. So let's split the middle term. You will have x square minus 2ax minus ax plus 2a square is equal to 0. I'll take the x common. You have this. So the two factors are x minus a, x minus 2a. Right, that means x can either be equal to a or it can be equal to 2a. Now, to understand whether it's increasing maximum or minimum, you have to find out the second derivative. So f double dash x will be given by 12x minus 18a. right? Now at x is equal to a, solve it. And for this value and this value, f dash dash x is 12a minus 18a, which is minus 6a, which definitely is less than 0 because a is greater than 0 in the question, right? So that means x is equal to a is point of maximum. Similarly, at x is equal to 2a, f double dash x is equal to 12 into 2a minus this 24 minus, which is equal to 6a, which is greater than 0. Therefore, x is equal to 2a is a point of minimum, right? That means alpha is equal to a and beta is equal to 2a. You are given 2 alpha plus beta is equal to 8, which means 2a plus 2a is equal to 8, which gives you a is equal to 2. That's it. You needed this value. A is equal to 2. Yeah. So that means you have option B as the correct answer. Hope you got that. Let's move to the next 72nd question. If the radius of the sphere is measured as 9 centimeter with an error of 0.03 centimeter, then the approximate error in calculating its surface area is given by. Okay, area of the sphere is given by 4 pi r square, and if I find the derivative of it with respect to r, this is equal to 8 pi r into dr, right? And 8 pi, the radius is given to you as 9 centimeter, and dr is given to you as this. So you have 8 pi into 9 into 3 upon 100. So this is 2, this is 25. Or I don't need to go for this. Don't do the cancellations. So you have 27 8s are 216. So 2.16 pi centimeter square. All right. This is the answer to the question. Find the approximate error in calculating the surface area is 2.16 pi centimeter square. That is option A is the correct answer. Hope you got that. Next, 73rd question. The diameter and the altitude of a right circular cone at a certain instant were found to be 10 centimeter and 20 centimeter respectively. If its diameter is increasing at the rate of 2 centimeter per second, then at what rate must its altitude change in order to keep its volume constant? We are talking about the right circular cone, right? So here the volume is given by 1 by 3 pi r square h. If I find the derivative with respect to r, this is given by pi by 3 2 pi r h dr plus r square into dh. Okay, you are given certain things that the diameter and the altitude. Okay, you are given that the diameter is equal to 10. So radius is equal to 5. And altitude, that is h, is equal to 20 centimeter. These are some of the figures which are given to you. Let's find it, fill in over here. So this becomes pi by 3 into 2r, that is equal to 5 into h into dr. Yeah, if its diameter is increasing at the rate of 2 centimeters per second. So this is equal into 1. See, here I have dr. dr, what is r? It is the half of the diameter. So question number 73, the diameter and the altitude of a right circular cone at a certain instant were found out to be 10 and 20 centimeters respectively. If the diameter is increasing at the constant rate of 2 centimeters per second, then what is the rate? Then what rate must the altitude change in order to keep the volume constant? First of all, you are having a right circular cone. right? And the volume of the cone is given by 1 by 3 pi r square h. Let's find the derivative of this volume. This is given by pi by 3. This is a constant. I'll keep it outside. So this is 2 into r into h into d r plus the second function derivative that is given by r square into dh. Okay. So now if the volume is constant, that means this is equal to 0. That is equal to pi by 3. And let's discuss some more terms. You are given that diameter is equal to 10 centimeter, which gives you radius as 5 centimeter. Height is given to you as 20 centimeter. Also, you're given diameter is increasing at the rate of 2 centimeter per second. So if diameter is increasing at the rate of 2 centimeter per second, then the radius will be increasing at the rate of 1 centimeter per second. Sure, because diameter is the double of radius. So let's fill in the values. You have 2, radius is 5, h is 20, and dr is 1. 5 into 20 into 1 plus r square gives you 5 square, and dh I have to find out. This gives me 0 is equal to, that is equal to 200 plus 25 dh, or dh comes out to be minus 8 centimeter per second. That's it. You have option D as the answer. Of course, if the diameter is increasing, height has to be decreased in order to keep the volume constant. Hope you understood this. Next is 74th question. Integral of sine alpha upon 1 plus cos alpha d alpha is equal to. Okay. So this is the integral function. Let's see, multiplying the numerator and the denominator by root of 1 minus cos alpha. So you can write it as sine alpha upon, this can be written as 1 minus cos square alpha into d alpha, right? Because root of 1 plus cos alpha into root of 1 minus cos alpha will be equal to root of 1 minus cos square alpha. Correct. So this is equal to sine alpha into root of 1 minus cos alpha divided by sine square alpha root, that is equal to sine alpha, and they will cancel. That's it. So you have to find out the integral of root of 1 minus cos alpha d alpha. That's given by 2 sine square alpha by 2 d alpha. This will be given by sine root 2 will be taken outside, sine alpha upon 2 into d alpha. So that's easy now. This will be given by root 2 sines integral is equal to minus cos alpha by 2 into divided by 1 by 2. So that's going to give you minus 2 root 2 cos alpha by 2, which is option, of course, plus the constant c. So we have option A as your answer. Hope you understood. Next is 75 question. If integral of cos 4x plus 1 divided by cot x upon tan x is equal to k into cos 4x plus c, then k is equal to. Okay. So let's start with the sum now. 1 plus cos 4x. This can be written as 2 cos square 2x upon, now let's open the cos. See, 1 plus cos 4x is equal to 2 cos square 2x. Okay. And now the denominator, you will write it as cos x upon sin x minus sin x upon cos x dx. That is integral 2 cos square 2x upon cos square x minus sin square x whole divided by sin x into cos x dx, which is given by 2 cos square 2x. And this is also equal to cos 2x into sin x cos x dx, right? So this will cancel with this. And you have integral of, I'll take 2 outside. Okay, let's take, okay, no, keep it here. So this is cos 2x into 2 sin x cos x dx, or that is equal to cos 2x into sine 2x. If I'll divide and multiply with 2, this will be equal to integral of sine 4x dx. This is equal to 1 by 2 into sine's integral is minus cos 4x divided by 4. So this is minus 1 by 8 cos of 4x plus the constant c. Okay. Now this is equal to k for k cos 4x plus c. So this is equivalent to k cos 4x plus c. That means k is equal to minus 1 by 8. So you have option B as your answer. Hope you understood this. Next is 76th question. If integral of cos x dot d by dx of cosecant x dx is equal to fx plus gx plus c, then what is the product of these two functions? So this is integral of cos x, and the derivative of cosecant x is given by minus cot x into cosecant x dx. So this is given by minus of cos x into cos x upon sin x into 1 upon sin x into dx, or that's equal to minus cos square x upon sin square x, or better to write cot square x dx, right? Now this can be written as minus cot square x. This can be written as 1 minus, I'll take this inside. So 1 minus cosecant square x dx, right? Now this derivative is given by x plus cot x plus c. Now this was equivalent to your fx plus gx plus c. Fx plus gx plus c. So fx is equal to x, gx is equal to cot x. You had to find out fx into gx, which is this. So you have option A as your answer. Hope you got that. Next is 77th question. If integral of 2x plus 1 raised to power 6 upon 3x plus 2 raised to power 8 dx is given by this plus r, then what is the value of p upon q? Okay, so let's start with this question. I'll start with the LHS. 2x plus 1 raised to power 6, 3x plus 2 raised to power 8 dx. I'll write it as integral 2x plus 1 raised to power, or I'll write it like 2x plus 1, 3x plus 2 raised to power 6 into 1 upon 3x plus 2 raised to power 2 dx is equal to. So I'll say now, let's say 2x plus 1 upon 3x plus 2 is equal to t. Let's find the derivative. So you have 3x plus 2 square into 3, sorry, in the numerator, it's 3x plus 2 into 2 minus 2x plus 1 into 3 is equal to dx is equal to dt. Or you will write it as this only. Okay. So that makes 6 minus 6x plus 4 minus 6x minus 3 upon 3x plus 2 square dx is equal to dt, or you have 1 upon 3x plus 2 dx is equal to dt. Now this integral becomes, from equation 1, let's say, from equation 1, you have integral of t raised to power 6 into dt is equal to, this integral is given by t raised to power 7 plus upon 7 is equal plus c. Now, this was equal to this. Let's write it down. This is equal to, first of all, 2x plus 1 upon 3x plus 2 raised to power 7 divided by 7, or I will write 7 over here. This was equivalent to P into this raised to power Q plus C. R, sorry. Okay, what we had to find out is P upon Q. So P over here is 1 by 7 and Q is equal to 7. That's for sure. And you have to find out P upon Q. So that becomes 1 upon 7 divided by 7. That is 1 upon 49. Okay, so you have 1 upon 49. That is 1 upon 7 square. That is option A as your answer. Hope you got that. Next, 78th question. Integral limit 0 to a dx upon 4 plus x square is equal to pi by 8. Then what is the value of a? Okay, you are given this integral 0 to a dx upon, this can be written as 2 square plus x square. So, you know, this integral will be equal to 1 by 2 tangent inverse x upon 2. The limits are 0 to a. This is equal to pi by 8. So 1 by 2 tangent inverse a by 2 minus tangent inverse 0 is equal to pi by 4, I'll say. All right. So this is equal to tangent inverse a minus 2 is equal to pi by 4. See, this is, you can say a by 2 is equal to tangent of pi by 4, and that is equal to 1, which gives you a is equal to 2. That's it. You needed to find out the value of a, and option B is the correct answer. Hope you got that. Let's move to the next question. Question number 79, integral limit 1 to 2 x cube minus 1 upon x square. I will split it up. So x cube upon x square minus 1 upon x square dx is equal to limits 1 to 2. That's x minus this into dx. So let's find the integral. This will be equal to x square upon 2 plus 1 by x. Limits are from 1 to 2. This is given by this pretty easy equation. So this is 4 upon 2 plus 1 by 2 minus 1 upon 2 minus 1 upon 1. So you have this as 2 minus 1, which is equal to 1. Therefore, you have option C as the answer. Hope you got that. Then let's move to the last question of this paper, mathematical question. The solution of the differential equation 2x into dy by dx minus y is equal to 4 represents a family of. Okay, so you have a 2x into dy by dx is equal minus y is equal to 4, or you can say dy by dx minus y upon 2x is equal to 4 upon 2x. Here, the integrating factor is given by e raised to power minus 1 upon 2x dx, or this is equal to e raised to power, this will be log x upon minus 2. So this is equal to 1 upon root x, right? Now, 1 upon root x into y is equal to integral of 2 upon x root x into dx, which can be written as the y upon root x is equal to 2 into, see, this will be x raised to power minus 3 by 2 plus 1 upon this, because this 1 upon x, this is equal to this. Okay. So that's going to give you y upon root x is equal to 2 into x raised to power 1 by 2 upon minus 1 by 2. That is equal plus the constant c. That's equal to y is equal to root 2x. So this is equal to 2 2s are 4 minus actually x raised to power 1 by 2. That is root x plus c, or y is equal to c root x minus 4. That's it. Or you can say y plus 4 is equal to C root x, squaring both sides, you will get y plus 4 square is equal to c square x. This represents a parabola, right? So we have this represents parabolas. Option B is the correct answer. So with this, students, we have completed all the 80 questions of this paper. Hope you have understood them well. A very best of luck for your exams. And don't forget to visit our website www.examsnet.com. To practice this and many more entrance exam question papers, you can also download our app. The link is available in the description box. So keep shining, keep rising high. Best of luck. That's all for this paper. Bye.